the randomized opportunities.
All right, good morning. Thanks so much for having us on the program. Really an honor to be here, especially to kick off the ultimate day of the Summer Institute. This work is joint with Meltem Desal and Emil Simonson, who are here and will answer lots of good institutional and data questions for me. And then Naeem Samandari and Mirsha Trandafir are also on the paper. And so we'll just start with the number of refugees or displaced people over time has really been growing, especially recently, thinking 100 million people in the world are displaced. And it really affects children more. So here for children and families, I think is particularly appropriate. Something like 40% of all refugees are children compared to 30% of the global population, so they're disproportionately represented. And then the parallel motivation for the paper is that there's a lot of interest in social mobility measures, economic opportunity popularized by the Opportunity Atlas. So here's just a map of the US looking at counties for what are the earnings for children who are born in those counties when they turn 35. And you can see there's tons of heterogeneity, especially in their small area variation where neighboring counties could be off by a factor of 2. And so there's this interest in, well, what is it about the place that matters? And maybe we could even use place-based policies to improve child well-being. So the question we're trying to answer in this paper is, does growing up in an area with higher economic opportunity result in better outcomes? So we're trying to get that causal effect. And the idea that we're going to use to get there is a quasi-random assignment of refugees in Denmark over a 12-year period. So we'll have like 10, 12,000 refugee children who are sprinkled about Denmark. And we want to know where were they sprinkled? Does that matter for their long-term outcomes? And we want to make a number of contributions here. We're going to measure economic opportunity in Denmark. So you know those maps here in the US and lots of other countries, we're going to add Denmark to that. We're going to look at place or area effects for a vulnerable group. These refugees have very poor outcomes when you compare them to the local population. And so it's interesting to think about, well, where do they grow up? Does it matter for where they end up? On a measurement side, we're going to look at a predetermined measure of opportunity. So when people arrive into the country, something that you could actually use to assign them to a place, as well as it doesn't suffer from a reflection problem that you normally get with pure effect type of analyses. As well as we'll look at contemporaneous measures. In other words, how do kids that they grow up with, how do they do? How is that correlated with their own outcomes, which is more in line with the literature. And it takes into account these kind of common shocks that you might expect. We're blessed in Denmark to look at a wide set of welfare relevant outcomes. And then we're going to begin to unpack some mechanisms. So we're going to look at age at arrival. It's going to be some surprising results there, I think. Then we'll look at the places where the refugees go. How does that affect the parents' income? We'll look at group-specific opportunity measures to see if it loads up on particular types of subcategories. And then what I'm particularly excited about are the area characteristics. So first, just characterizing where are the areas that have opportunity in Denmark? And then if you horse race economic opportunity versus a pretty wide range of other characteristics, economic opportunity does turn out to be a very particularly strong predictor of child well-being measures. So it bolsters it as a measure. So just as a preview, assigning refugee children to high social mobility areas results in more employment and earnings. Not that big of an effect on educational attainment. So thinking about mechanisms, we might get some insight there. Substantial reduction in crime, particularly property crime, lower foster care placement and teen motherhood, and higher refugee parental income. Like I said, opportunity turns out to be a particularly strong predictor of adult outcomes. For income, there's one that rivals it, which is area inequality. And I'd love to hear from you guys, but I don't know a lot of causal papers that shows that the area where you grow up, the inequality in the area that you grow up actually impacts your outcomes in the future. People are interested in inequality for lots of reasons, but having some more causal evidence that it actually has this welfare relevant outcomes, I think is really interesting. And higher opportunity impacts earnings and crime outcomes. For example, in the horse races, the area income doesn't beat out economic opportunity in terms of your own income. And area crime doesn't beat out opportunity in terms of your crime outcomes. So it's just, for some reason, it's particularly strong. And then this age at arrival, like I said, it's going to be interesting when you look at, if you arrive in Denmark at a young age, you do way better than if you arrive at later age. So like there is this idea that moving to Denmark actually is the move to opportunity that might even be bigger than this cross-sectional variation we'll be exploiting today. All right, so I won't go through roadmaps very much because we don't have much time, and I won't go through the background as much as some of you might like, given that a lot of you have written in this area, so apologies if I go through that quickly, but there's this large literature on economic opportunity with substantial geographic variation and intergenerational mobility across places, including small places like across counties. And when I think about the causal literature here, I'm thinking about two main streams. One is experiments like moving to opportunity. And then there's a mover exposure design, which we'll exploit here too when we look at the locals. And the idea there is if siblings move at different ages, if it's plausibly exogenous, the timing of the move, that you could compare the younger and older siblings, where the younger one would have more exposure to the new area. And then there's tons of research on refugees. I'm not doing any of this the service that it deserves, but there's a really nice review piece that just came out not too long ago that says that most of that literature focuses on the refugee adults and that and issues a call for more research on children. So we're trying to fill some of that gap. Certainly, there have been other papers on this, but it's been much less than the adult side. There's been some findings here. So greater assimilation for younger refugees makes sense, and lower earnings for adult migrants. They tend to do poorly relative to the locals. The adult experience, how they're treated when they get there, include like language training or daycare opportunities, do benefit the refugee children, according to some nicely identified papers. And then when we look at, or the literature has looked at spillovers on the local peers, like the elementary school kids they go to school with, it doesn't seem like the refugees are having a negative impact on them. And then just going down this sort of fractal, there are papers on refugee dispersal, of course, and especially in places like Sweden and Denmark. The prior work has established, I think, pretty well that the Danish one is particularly nice in terms of a natural experiment. It's pretty rules-based, not a lot of non-random assignment there. The people have looked at health outcomes and income outcomes, especially among the adults. Social integration in enclaves has been a particular interest. So if you put people in an area with more people like them, does that help them or hurt them? And we'll get into that a bit in our results. And the closest paper to ours, a paper that really motivated us and a paper we're big fans of, is the Dom and Dustman paper that showed for this dispersal policy, the kids who went to areas with higher crime were more likely to have criminal justice involvement themselves. And so we're going to be thinking about expanding on this Dom and Dustman paper by looking through the lens of economic opportunity, a measure that we're particularly interested in learning about in a causal framework. So let me describe the refugee settlement process. So we're going to be looking from 1986 to 1998. 65% will be coming from the Middle East, 25% from East and South Asia, 10% from Africa. And the assignment decisions we're calling the quasi-random allocation of municipalities because there's this Danish Refugee Council, and they don't have any face-to-face meetings. They're going to be assigning the refugees to the municipalities where they're going to end up. And they do have a questionnaire, though, with basic demographic information. So that basic demographic information, we're going to show results with those controls. But conditional on those controls, it's hard to think about other ways that they would be targeting particular refugees to particular areas. About 90% of the refugees receive permanent housing under the dispersal policy. And there were big incentives to remain where you were placed because they had welcome programs, basically language classes, housing. And my understanding is that that would be hard to get if you moved away from the place that they assigned you to. All right, let me get into some data descriptions. So that we're going to use data administrative records covering the full population from 1980 to 2022. So when we're thinking about measuring income for parents and intergenerational, we can get back to 1980. The study refugee children arrived between 0 and 17 and were dispersed across 278 municipalities between 86 and 1998. Interestingly, in the early 2000s, they consolidated a lot of these municipalities to larger areas. If we use those areas, thinking maybe they would be more representative of the area effects, we find pretty similar results. We're going to measure parent income for the primary earner, including zeros. We'll clean up some of the outliers with some mensurization. Measure everything in 2015 US dollars. The child municipality will be assigned based on the mom's municipality. If that's missing, we use the father's. And we restrict to parents who are what we call permanent residents. During the years we measure their income, and they should be in the same municipality for the 5 years that we're going to average their income, so that it's trying to get a marker of the place itself. Yeah.
So you mentioned that there's a strong incentive to stay, but does that, you tend to think about immigrants staying in enclaves, or, being attracted to places where prior migrants came. Is that not so much happening?
Well, because they have this, pretty strong economic incentives, financial incentives to stay where they were. We have, if you want to think about a first stage, which is the average exposure to opportunity in the areas where kids grow up based on the area exposure where they were assigned. It's highly linear, and the slope is around 0.7. So if you want to divide all my estimates by 0.7, we're going to be like intent to treat conservative here today, but I'm all for that.
Right. Where people other places where.
It was certainly incentive compatible for the organizers of this dispersal to have they wanted to sprinkle people out instead of concentrating. Yes.
So permanent resident here is not like a legal.
No,
status, right?
that's why it's kind of,
Yeah.
I put italics in my voice. I don't know if you heard that, but it just that means that they stayed there the whole time we measure their income, so we can characterize the place.
Started in 1998, there was a big shock in Denmark after the Syrian civil war broke up. So there was a lot of Syrian refugees at the door as well at that time.
Yeah, we've looked a bit into the later years. I'm going to defer to my Danish colleague. So yeah, Emil, go ahead.
Yes, no, so there was a change in the way that refugees were dispersed in 1999, and so we just restrict to the old dispersal policy to avoid having this reform in the middle of our.
All those neighborhoods were affected by the refugee influx though, after
What's that?
those neighborhoods were affected later on by that influx though, right?
Yeah, but the characteristics from the municipalities are, we measure those at the year of arrival, so it's during this period.
Yeah, we're going to argue the impacts of other things are going to be orthogonal to where they were placed because of this random assignment of the refugees. But it's certainly something we could think about as an additional control. Just to describe these kids when they were arriving, so they're arriving around age 7, half are male. The age of the parents are around 36. The first arriving parent was typically male, 70%. 90% of the parents were married. They come number of kids in the family, so number of 0 to 2-year-olds about 0.45, and then one thing that we like about this project is those age and demographics of the kids and the family were known to the placement officer, but they don't have information on the education of the parents. So we have what we think of as like a killer control here, or a balance check control, which is the education of the parents, and we can show that that's balanced across places where people go, which would be consistent with the quasi-random assignment. Okay, let's measure opportunity in Denmark. We're going to have 2 measures of opportunity to capture social mobility. The first we call realized opportunity. This can get confusing later, so if you're going to zone in and out, this is one time to listen up. So we have realized opportunity, which is predetermined. When the child arrives, how are the 30-year-olds doing in the area that they arrive versus their parents? Okay, so the social mobility of the 30-year-olds when they get there, that's something that you would actually know, and you could use in an assignment policy if you wanted, as well as it doesn't suffer from kind of a reflection problem. And that relates income of locals aged 26 to 30 to their parents' income measured 2 to 6 years before the child reached age 30. There are some choices of when you can measure things, and we're trying to squeeze it into this box 1980 onward. We've done a lot of checking on this, and we're not worried about robustness to how we actually measure the parents and kid income. Yeah. I didn't understand, sorry. This is among locals. Yeah. Well, we measure the parental income in all these relationships. They had to have been in the area that we care about for the years in which we measure them. That was this permanent resident discussion we had earlier. And then the other measure, which is more in line with the literature, is this ongoing, what we call ongoing opportunity, which is defined for the birth cohort. So for a child born in 1980, how are the other kids born in 1980 going to do relative to their parents? And so that'll take common shocks, and it'll be interesting to think of it. This will be more powerfully related to the kids' incomes because it includes any kind of macroeconomic shocks that these kids will be facing. But it's not something that you could use at the time. It's only measured with a lag after people arrive. And we're going to shrink all the estimates with empirical base. Okay.
So the parents have to be living in the same municipality as the children or not?
When we measure the parents' income, they have to be in one municipality for all those years.
But could it be a
For-
different municipality for children?
Yes.
Because usually you fix where the kids are in.
Yeah, that's right.
And that's the location regardless of where they end up, where
Yeah.
the parents end up.
That's right.
So you're.
Yeah. Absolutely. And this is a typical QQ plot that you see in the opportunity type papers, which is the quantile of the child's income versus the parents. And it has a slope of 0.13 and intercept around 45. So if your parent income was at the bottom of the income distribution in Denmark, you can rise to like the 45th percentile, it's a more equal society than other ones. And also the slope here, 0.13, is flatter than in other countries. Another measure of social mobility, how mobile are you, would be a flat curve would be highly mobile. If we put this in context with other papers, in the US, the slope is more like 0.3. Other places around the world, the number is closer to 0.2. But in our measures, 0.13 to 0.16 is on the low end of that distribution. Yet still, there's a lot of variation if we look at across the range. I'll show you a map later that shows that variation. All right, so if we estimate opportunity following the literature, again, you're going to have on the left-hand side the child's income rank, and on the right-hand side the parental income rank. And we allow the intercept to vary by municipality cohort and the slope to vary by municipality cohort. And this, if you were here yesterday, you saw this as well. And then the opportunity measure is the predicted value at a particular point there at the 25th percentile, which is just following the convention. It's going to vary based on this alpha and the psi, the intercept and slope. And we can look at those two things separately. If you're interested in over time, the dark line here is the realized opportunity, and that's fallen over time from about 50. So again, that's where do people end up if you're in the 25th percentile, where if your parents were 25th, you'd end up in the 50th on average. That fell over time to 48. And then the dotted line is the ongoing opportunity, which these are, if you remember, realize this based on the older folks, and then the ongoing is more current folks. So you can almost think of that as a continuation where it starts off lower, just like the realized opportunity ended up a little bit lower at the end of the time period. Still, we've blown it up from 47 to 52. If you look at that scale, it's not that steep. Yeah.
So it's the reason you're not measuring kids at a later age, constructing this because you want to go further. You want it like.
Yeah, we're constrained by the times, and I have, I could show you some plots of like data we have and when we can measure it, and we've played around with those windows. Fewer years, but later in their life versus more years, where you get a better measure of the average over a slightly younger period. And again, we're
it probably doesn't matter much doing, but I think concerned that the rank of 21.3 probably be a bit higher after age 35 or 40.
Yeah, and we could do things like for subsets measure the we'll get noisier estimates, but we can see at that point estimates going up or down and report on them. Thanks. Yeah.
Give a sense of where the refugees would fall. I mean, should you use like 10? I don't know. Is it better to think about where the refugees start?
The refugees are concentrated from 0 to 40. So I think 25 is not a bad number. And here's a map. In Atlas papers, you need a lot of Atlas maps. So the range goes from 44 to 54. So I think later on, if you look at our coefficients, you could think about a 10 percentile point going from the very bottom to the very top of the opportunity measure. And we marked a few cities here like Aarhus, Odense, and Copenhagen. Those cities, if you look at them, they tend to be darker, so lower opportunity, but the suburbs around them tend to be lighter. And so maybe that gives us some hints. And then yesterday there was this question of how much does the intercept vary versus the slope. And so we wanted to show that if you look at the intercept, that's going from 37 to 52 at the bounds, and the slope is going from around 1 to 3. So there's variation in both the intercept and slope, and we could put those in together and horse race them. Yeah.
Things that they do a lot in these atlas papers is like correlate these measures with other characteristics of areas, like unemployment rates.
Yeah. We're going to have a whole section about characterizing these guys, but think about, there tend to be lower population, they tend to be higher employment. So good things on income, and they tend to be smaller in population. So for a mover exposure design, what people do is they have the change for, these are among locals, local Danes. They're moving from one municipality to another. And we look at the change in the opportunity in the areas where they originated and where they were destined to go. And then you have age indicators, and then you interact the age indicators with that change. I'll skip some of the summary stats here, but if you look at without any kind of fixed effects in this model, we have the native movers. If you moved when you were age 1, yeah, the coefficient on the change in ongoing opportunity would be about 2.5, and then that slides down, and 17 has been normalized. I think importantly, you want to look at them with the family fixed effects. This is where you get a bit more stronger causal story, and it gets noisier as you want to see. Interestingly, I've looked at a lot of these papers. They often find kind of flat until age 10, and then as you go from 10 to 17, you get this slope down, and we see a similar pattern if you squint. If you were to summarize this as a slope from 0 to 17, it would be around minus 0.09. And then if you look at ongoing or realized opportunity, this is without family fixed effects, this is with, and again, it's kind of flat and then it kind of goes down. It's a bit noisier. The slope, interestingly, with or without family fixed effects is always minus 0.05. And that's kind of in the heart of the literature when I look at other papers around minus 0.05. So it turns out realized opportunity, we get that. In terms of ongoing opportunity, which is actually what the literature is doing, I'd say we get a bigger mover exposure elasticity than other places. Yeah.
Curious whether you accept Danish-born children of refugees or other immigrants as part of the native population.
That's interesting. Emil?
These are needed. But these are needed by immigrants to be there.
We can measure opportunity among local Danes and among immigrants, and we can see which one might help refugees more if you grew up in an area where the locals do well and the immigrants, and it turns out it's good for both. So. All right. So that concludes the local Dane portion, and let's get to the refugees. So we're going to look at child outcomes of the refugees. For child I arriving in municipality M in year T, country origin O. W is going to be these municipality characteristics. Primarily, I'm going to look at realized opportunity for most of it. We can control for X's, and we're always going to be controlling for year of arrival fixed effects and origin, country of origin fixed effects. A little bit small to see here, but here's a balance table, which shows that if you're looking for stars, the characteristics of the kids when they arrive aren't that related to the realized opportunity in the areas where they go. If you look at the age of the parents, it's a coefficient of 0.004. So if the realized opportunity went up by 10, the average age of the parent would only go down by 0.04. If you look at male child, that's the one that has stars on it, that their male children would have a realized opportunity went up by 0.09, and the mean here is 49 with a standard deviation of 2.5. So those are, to me, economically small. Also, they were observed at the time, but the things that were not observed are at the top, which is the education. So the academic education of the parent, which is predictive of child outcomes, isn't really related to the realized opportunity in the area, which is consistent again with that was unobserved to the people making the placement and observed to the econometrician in this case. Okay, here's just a scatter plot of the ongoing opportunity on the x-axis and the child rank and the y-axis, and you see the slope of 0.66. It's a positive relationship. If you send kids to an area with higher ongoing opportunity, they rise in the child income rank. And this is, again, that ongoing opportunity. This is for realized opportunity, you get a more muted effect of the slope is 0.35. And that makes sense to us because it doesn't incorporate these common shocks, but it's still a strong relationship. And if we put that into table form, here we've for most of the rest of the paper, I'll be normalizing the realized opportunity to be mean zero, standard deviation 1. So to go up 1 standard deviation in realized opportunity would raise the income rank with all the controls by about 1.4 percentile points. Sometimes in the paper we say if you go from low to high, 2 standard deviations, that would raise your income by about 8%. So it's not the only thing that matters for your income, but we think it's a sizable effect. Yeah. Absolutely.
The salary of staff, he said educational attainment didn't improve, but so I wonder if that was a rule, something happens.
Yeah, I can get into the sort of first stage of where the people are assigned and how is that related to the experienced opportunity in the areas where they grew up. And the slope is very linear and the coefficients are around 0.7. So again, if you want to divide these by 0.7, you would get IV effect of realized opportunity. It's interesting. We want the intent to treat in part because you might go to a place and one of the good parts of that place is that it's a feeder to getting you jobs by moving you somewhere. Like we want to leave that in there as a potential impact. But when we push on that, we don't think that it's coming through people being more likely to move to Copenhagen if you went to a high opportunity area in a rural area far from Copenhagen. So we'll have more to say about that. Yeah, Hillary?
Could you bring in some sort of just raw correlation or difference in order to think about that 8%? Not sure what the right one would be. Certainly the refugee native gap, that'd probably be too big, but I don't know, just try to, in an equal society, it's like, I don't know, 8%, is that a lot or a little?
Yeah.
I mean,
How much?
just
is
like
the gap?
help us,
How much of the gap?
how much of the gap is closed? In fact, I don't know if that's the right gap to look at, but something.
Yeah, like I said, the refugees, they tend to be in the 0 to 40 range, and the locals tend to be in the 50s, right? Like that's the locals, the median there. So, if you're going from 40 to 50 or 35 to 50, think about a 15-point gap, and so it's going to close. If you go from low to high, something like 3 of the 15. That's all top of the head envelope. But there's an envelope on top of my head. So what I really love about this paper, though, is that you get a lot of outcomes from the Danish context. So, and we find pretty big effects here. So if you look at crime outcomes, for example, first of all, just the mean here, the share of kids, refugee kids who committed crime by the age, or convicted of a crime by age 30 is 36%. And we looked, I was like, wow, that seems big. Is that what the literature finds? And it's true. That's what the literature finds. If we look at the number of crimes, they're committing around 1.6 crimes by the age of 30. And if you look at that intensive margin, that's where we find these statistically significant improvements. If you go to an area with higher opportunity, you commit fewer crimes on the order of 0.1 fewer crimes for 1 standard deviation increase there. I'll have a summary at the end, but these are, think about 10 to 15% reductions in crime relative to the mean. And this, you were asking me about the human capital measures. I was thinking, one big reason why we're going to have a higher income is that they're going to be going to school longer. But if you look at years of schooling, you get a very small coefficient, 0.07, compared to a mean of 12 years. If you look at the probability of vocational degree, there's a hint of an increase there, a 1 percentage point increase if you went to a 1 standard deviation higher realized opportunity area compared to a mean of 35. And that number is bigger for boys. So there's some interest in vocational training, especially among refugees, and how impactful that could be. We find hints of that. I wouldn't say that it's as large as some of the literature has found in other contexts. If you look at just employment as one measure of how you get higher earnings, it does go up by 2 percentage points. And then the earnings itself, instead of the QQ rank, the quantile rankings, the earnings goes up by $860. Yeah.
So another way to think about it is how do the impacts compare to the counterfactual, which is really what we should have to So there's the data in Sweden, I can't remember. It's a good trust with that.
That's a great point. Yes. I don't know the answer. My envelope is falling off my head. But yeah, I don't know the answer to, I should know from the literature. There are mixed results on the enclaves. Is it good to go to an enclave, bad to go to an enclave? I think in Sweden it wasn't good, but the other places it is. So, but we could certainly put the numbers in context with them.
That might be one why the cities to be particularly bad. If you go to Copenhagen, you can find your.
Yeah. We've dropped the big cities too to see like what happens if it's all about these little areas, and the results are stronger if you just get rid of the big cities, if I remember right. So we've been playing with that and we should talk more about that in the paper. How much of this is a Copenhagen Aarhus effect, and that we don't think that that's driving the story at all, which was interesting. I thought it would be, yeah. And then comparing to where people normally go, which would be Copenhagen Aarhus, that's why they were going there all the time before, and why they sprinkled them. We could do a direct estimation of that. That's a good idea. Yeah, Jim.
Spot realize not about with refugees.
Yeah.
I guess if you estimated both, you have this idea of the sole ladder problem, like you have all refugees in the high opportunity places, or
Sure.
how do you make that trade off?
Yeah. Yeah, you definitely don't want to send everybody to the tiny town in northern Denmark. That's the #1 on the opportunity atlas. That's absolutely true. We're going to show you some municipality horse races in a minute, and one of them will be about co-nationals. All right, and then in terms of integration and other outcomes, so and fertility and marriage is what we had in mind. Teen motherhood goes down by about 0.003 compared to a mean of 0.03. So we found that to be interesting, and then probably that your parent at all by age 30 goes down. If we look at things like, did you get married, cohabitated, did you get divorced? Those things are pretty tight nulls. We don't find effects on that. The probability that you're partnered with a Dane at age 30 as a measure of integration, we don't find going to an area with higher opportunity is more likely to have you cohabitate with a Dane by age 30. So just as a summary, a 2 standard deviation increase in realized opportunity, we're finding an income rank increase by 3 percentile points, employment going up by 9%, little to modest effects on educational attainment, criminal convictions going down by 13%, foster care placement going down by 20%, which I don't think I mentioned before, but a near and dear outcome to me, and then reduces teen parenthood by 19%. So to me, these are pretty substantial as we go from a low opportunity area to a high opportunity area. All right, so now let's get to like why these results might be coming. One idea is to at least to show you this sort of first stage figure, which is the realized opportunity in the municipality assignment on the x-axis, and the y-axis is the average exposure to the opportunity measure across your childhood years. And here we get that slope of 0.73 that I've alluded to a few times already. So it does seem like the random assignment did affect where you ended up growing up. All right, well, maybe one reason that kids do better is because their parents do better. And so we could plot the realized opportunity again on the x-axis and the parental rank on the y-axis. And here you get a slope of 1. So if you go up 10 percentile points in the realized opportunity, you're going to be going up 10 percentile points in the income distribution. And so that's a pretty strong effect. If we relate this to the correlation between parents and kid income for refugees, the correlation there, that relationship has a slope of 0.3. We put those numbers together and say if that's like an inflated, if with ability bias and other things, you might think that's an overstatement of the effects of parental income on child income. Then when we get an upper bound estimate that the parental income channel would explain less than 20% of the overall effect. So it's not nothing, it's definitely there, but we don't think that it's all coming through that the parents do better at the places where they're assigned, which would have been a fine mechanism by me, but it doesn't look like that's the full story. All right, let's think more about social integration. This is some of the more surprising results to me when we ran them. So this is just the raw, what age did you arrive into Denmark? And the y-axis is where do you end up in the income distribution as an adult? And you can see that intercept is around 20. So 20 percentile point increase in the income distribution if you arrive as a newborn compared to arriving at age 17. And it's pretty linear, and it doesn't really matter if we use family fixed effects or not. Just the age that you arrive is a big deal. And this is where I was saying you could think of moving to Denmark as a move to opportunity. Those mover exposure designs typically would have a change in the opportunity areas, but here it's just we don't know the opportunity in the area where they came from in Syria. So it's just that one-sided part of it, where do they end up going? And this is, again, age of arrival to Denmark as a whole. So think about Denmark versus Syria in this graph. So huge slopes here, and it speaks to integration, speaks to language. The literature is quite clear that this would be the expected result. And then a drum roll on if we interact this with the realized opportunity in the area that you go to, we just don't find any gradients. So if you grow up in an area with, as an infant in an area with higher realized opportunity versus if you were 17, we don't think that it doesn't turn out to be better for you. So the 17-year-olds do great. This is we saw that from the overall results. And the newborns aren't doing any better than how great the 17-year-olds did. To me, this was, somewhat surprising, and it helps think about some of those stories. Is it about language? We know that moving to Denmark, it matters for the language, but if you move to a high opportunity area in Denmark versus a low opportunity area in Denmark, the high opportunity areas aren't getting you to learn the language better, or it's not getting you like more Danish friends and things like that you might expect if you arrive as a newborn compared to a 17-year-old. So this helps rule out a lot of potential stories of why opportunity might matter, and help, I think this is one of our more powerful pieces of evidence on why this might be like. Yeah.
Maybe missing something about how this is different from what you were showing us before, where you also had age on them.
This one?
That, like the earlier.
The earlier one is the mover exposure design among the locals, where you regress the change, the income for kids on the change in the opportunity in the area where they came from versus where they went, and then you interact that with age. And the idea is that for older siblings, they don't have as many years in a new place as the younger ones. So if you compare a 17 and a newborn, that's going to have assumptions, just like our paper has plenty of assumptions. That'll have assumptions that the age, you don't move based on the opportunities that you might expect for your younger kids versus your older kids. And there's debate in the literature and even in the Wall Street Journal, it turns out, that about whether this is this identifying assumption is a good one. But we do find it in
the refugee regression showed us didn't take advantage of the timing. Is that I'm the connection across the different results, I think.
Yeah. Well, first we tried to establish that there's variation in this opportunity measure in Denmark. And then we wanted to see, sort of validate it by looking at movers among local Danes.
Yeah.
And we found that the little kids who move versus their older siblings did better in an area in Denmark. And now we're going to the refugees, where we have random assignments, quasi-random assignment. So I'm less worried about the identifying assumption. We don't find that there's an age gradient. More exposure. It turns out 17-year-olds do well. Remember, parents do pretty well. 20-year-olds, 30-year-olds, 17-year-olds, all doing well if they go to an area with higher realized opportunity. And the newborns don't do any better than the 17-year-olds, even within family. Yeah. Yeah, Amanda. Well, I've been thinking about that. Yeah, so it's different than we're not looking at this change. We're not controlling for the origin. We have origin country fixed effects, but not this sort of change. Yeah, I came to a place where I wasn't thinking that this throughout the mover exposure design. In other countries, like they're not always finding the mover exposure like mattering in Europe as it does in the US. So there's going to be heterogeneity across place. The other thing is in the mover exposure design, there's an intercept and a slope. And all this interest is in the intercept and maybe the slope, in the slope and the intercept might help you think about the selection. The people who move are different than the ones who don't move. But here we find with I'd say a causal framework, what happens to 17-year-olds, that intercept matters a lot, and it just turns out the slope doesn't. Yeah.
A lot of these Vanuatu and 5 to places, and also how the kids sort into schools between them in these kinds of areas, not just the law, but there was last schools, so they're spreading.
Yeah, I think that's a great idea for unpacking these pathways, is to think about how mixed our income, for example, are the schools that they end up going to, what is the quality of the schools that we're going to. This is on our to-do list to think about exactly those type of pathways, but I just don't have results for you today, but it's a great suggestion. Yeah.
On the school side, do you have tests?
Yeah, we have test scores.
Because that might just think that's the margin and not. for a lot of you.
So getting back to like the value added of the schools or the kid outcomes. Yeah. Yeah, no, that's a good suggestion. I have 5 minutes. It's fine. I'm happy to take your questions. Yeah, Amanda. Yeah.
We've just been exposed to conflict for much longer time, and how that plays through your results.
Yeah, that's a good question. So when I think about estimating this year by age. And so the 17-year-olds across these different countries of origin, they've all had a lot of their childhood in in a tough environment, and they moved to Denmark. And it turns out that if you go to a high realized opportunity area for those 17-year-olds, they do well. And then if you look at the newborns, they've had very little exposure to this war, and if they go to a higher opportunity area, they do well, but they don't do any better or worse than those 17-year-olds. So it helps us think about there's something not about language, maybe something not about the exposure to the war or where they came from, that's driving this ability for the area place effects to have an impact on you. But it's a little unsatisfying. I don't exactly know why the area is doing well, and we're going to keep chipping away at that. Maybe with 4 minutes, because so many people have been asking me about the municipalities, I want to get to that. So realized opportunity is negatively related to population size, urbanicity, non-Western immigration share, crime, Gini, and poverty. And it's positively related to employment rate and mean earnings in the area. So when I think about the labor market, mean earnings and employment in the area, those are good for opportunity. And crime and population size are not. I could show you this, but if you ran a lasso, employment rate and Gini would be the ones that are the characteristics that kind of are most predictive of the realized opportunity. This is our horse race type of regression. The first column here, we've estimated each municipality characteristics on the child income rank separately. So the first column, each cell is a separate regression. And so if you look at the top row, that's our baseline of minus 1.44 for realized opportunity. All of these have been standardized, so they're 1 standard deviation unit increases. And 1.44 is a pretty big number. It's bigger than most of them. And it's but there are plenty of things with stars. So if you go to a high population area, that actually hurts your income rank in Denmark. Higher employment rate is good, mean earnings is good. One that has a higher coefficient is Gini index, is minus 1.7. In the second column, we've horse raced these. So now realized opportunity is in the second column, and the other variable is in the third column. And if you look down the second column, it's realized opportunity, even controlling for the other municipality characteristic, is still a strong predictor of outcomes sort of down the board. And the other variables tend to lose that significance. If you look at the share co-national, people have been asking me a lot about that. That's sort of trying to get to this ethnic enclave. Remember, this is in the municipality, not in the neighborhood you go to. So with a grain of salt there, we don't find that by itself, the share of co-nationals in the area where you go is related to your income rank. And then if you horse race realized opportunity, it doesn't really move our coefficient on realized opportunity very, very much. To me, the surprising one here is the Gini. So the Gini, if you put Gini and realized opportunity, which are both measures of social mobility, if you think of it that way in a Great Gatsby type of way, it loads up on the Gini coefficient. And again, I don't know a lot of papers that have a causal framework to say that the inequality in the area where you grow up matters for your earnings outcomes. Let me show you one more. This is for crime. If you look at the second column, plenty of stars, and horse racing, realized opportunity tends to be a very strong predictor of crime, even horse racing, including with the crime rate. So that's, if I can look, here's the crime rate. If you look at the crime rate itself, if you go to a place with high crime, you're more likely to have crime outcomes, which is exactly the Dahmen-Dussman result. If you look at a horse race between realized opportunity and crime, the realized opportunity kind of wins out. So it's just, for whatever reason, when you go to income, Gini is particularly important, but when you look across our range of outcomes, it's the realized opportunity that tends to win the day. So we consider 11 municipality characteristics. The Gini coefficient is minus 1.7, poverty rate is minus 1.7, so those two are particularly strong predictors. Smaller for non-Western immigration share, mean earnings, share with high school, and crime. And this Gini and poverty tend to be particularly important predictors. Just really quickly, for boys, we find larger effects on vocational training, which is, we were looking for where could we find education results, and if there is any, that's where we find it. Boys also have larger effects on crime and foster care. So if, and foster care could be due to child behavioral problems. So we think of this as partly for kids with high crime rates, or for groups with high crime rates, you find bigger effects on crime. And girls, you find a slightly larger effect for income. I have 30 seconds, so let me get to my conclusions. We exploit this natural experiment in Denmark where refugees are causally randomly assigned to municipalities. And if you look at a 10-unit increase in realized opportunity, that would raise income ranks by about 16% or $2,700. We don't find a big effect on education, but it does seem to reduce criminal convictions, and this 10-point jump would be about a 14% compared to the mean. And then last, inequality tends to have a larger impact on income within this causal framework. Refugee settlement policy could consider like some complex combination of these. And I think Gini and poverty would be clicking there for if you cared about income. I found that moving to opportunity looks like a big move to opportunity, which I thought was interesting. And then refugee parents benefit from settling in areas with higher realized opportunity. I'm happy to answer more questions later, but I think my time is up. Thank you.
Great, thank you very much. Am I good to start? Okay. Well, thank you so much, Jana and Anna, for putting our paper on the program. I'm Riley Wilson. I'm going to be presenting some joint work with Mike Andrews, who's here in the room, Ryan Hill at Northwestern, and then also Joe Price, who is my colleague at BYU and is here as well. And really, thanks for putting this paper on. I think it fits pretty well with some of the work that we've seen, especially with the paper we saw yesterday morning from USA, thinking about the role of these neighborhoods on children's outcomes. In particular, we're going to be thinking about how do childhood neighbors affect children's long-term labor market outcomes with the focus on occupational choice. So luckily, Joe teed me up really well here. So we have lots of really good evidence that your childhood neighborhood matters for your long-term economic outcomes. So if you think of the moving to opportunity literature or any sort of adjacent literature there, we have some really good evidence that your childhood neighborhood has a causal effect on your long-term economic outcomes. But what is a little bit less clear is exactly why these neighborhoods matter. What is the causal mechanism that's leading to these changes? And there could be lots of things going on. We can sort of classify this into, I think, sort of two big bins. One, it could be a place effect. It could be something about the particular place, the institutions, the amenities that lead to changes in resources and investments in children in a way that affects their long-run outcomes. But just as easily, you could imagine it's something not so much about the institutions as it is the agglomeration of people who live there. And so you could imagine that these local neighborhoods form networks in a way that transfers information and role modeling and mentoring in a way that changes children's trajectories. So both of these things could be going on. We're not going to make an argument that it's one versus the other, but what we really want to do is want to explore the second channel and think about what is the role of neighbors, the people in the area, and how does that affect these long-run outcomes? Okay, so we're going to do this in a particular setting. We're going to think about how do adult neighbors influence children's later life occupation choice. If you think of the existing literature on localized networks, there's a couple of patterns that emerge. So first, we see that as we look at peer networks, if you sort of think of these horizontal networks, we see strong patterns of transmission of educational choices, occupation choice, transfer of information. So these horizontal networks across peers really matter. But we also see really strong intergenerational transfers as well. And so what we're going to do is we're going to say, well, let's sort of go one step beyond that and sort of think of these cross interactions between unrelated adults and children within localized geographic areas and see if they affect children's long-run outcomes. And so you can imagine if there are these localized networks, the neighbors that you have as a child could transfer information or preferences or resources to you in some way that changes your outcomes and could potentially be quite meaningful for you. And so we're going to be looking at a setting in early 20th century American neighborhoods where we have very high neighbor-to-neighbor interactions. So we have these very strong localized networks, and we're able to exploit some very hyper-local variation in the neighbors that you live next to see how does that affect your occupation choice. And one thing I really like about this, and I think is complementary to Moises' paper yesterday, is we sort of have this geographic accessibility problem where people who live next to each other have access to the same jobs. And we're able to sort of hold that constant and think about, is there some separate individual effect of living next to someone in a particular occupation? And does that change your occupation choice? Okay, so what we do is very simple. Imagine you have a neighborhood where you have a boy, Max, who lives next door to Dr. Smith, and he has a classmate, Carl, who lives just a little bit further away. All we're really going to do is we're going to just compare and see, is Max more likely to become a doctor than Carl is? And then we're going to replicate this for millions of children in lots of different neighborhoods, across lots of different occupations. Yeah, so you might think families are going to agglomerate and live next door to each other. So we can show that it's not driven by that. I will get to that a little bit later, but remind me, I'll probably forget to talk about it. But yes, so this is not just you're learning from your uncle. Okay, great question. Okay, so essentially we're going to exploit this very hyper-local variation in who you're living next to and see if you're more likely to go into a particular occupation. To do this, we're going to be exploiting the fact that historical censuses in the United States were enumerated by hand, door to door. And so we can take the actual enumeration of this to reconstruct the microgeography of neighborhoods. So we can observe who your neighbors are. And then we're going to combine this with recent advances in census linkages through the census tree data, which comes from a big project by Joe and Casey Buckles and others, to be able to link children from 1910 to their adult outcomes 30 years later in 1940. So then we can see you in 1910, we see where you end up as an adult, and we're going to then be able to compare your future occupation choice of children who were living next door to people in particular occupations relative to other children that were growing up on the same street. And so if you think of our strategy, this is sort of a glorified matching design. Really what all we're doing is we're just saying conditional on living on a particular street, the occupation of your next door neighbors, if it's as good as randomly assigned, then we have some exogenous variation that we can consider what's the treatment effect of being exposed to someone, a neighbor in a particular occupation. And so we'll spend some time sort of, I don't know what I did, but we'll spend some time thinking about the identification strategy. Okay. We find that neighbors do matter. Yeah. Yes. Yep. If they have same age children as you. Yeah, so we do see some patterns of that. So I'll get to this in just a minute. I'll highlight it and then we'll show you in more detail sort of what's going on. But we sort of see these patterns which would be consistent with stronger connectedness, like you're thinking there. So overall, we find that these neighbors do matter. So next door neighbor children are about 10% more likely to enter into their next door neighbor's occupation relative to other children that are growing up on the same street. And we can do all sorts of things to try and get a potential selection and sorting into these neighborhoods. And we find that these effects are fairly robust. But I think sort of just as interesting as this average effect is just the vast amount of heterogeneity that we observe. So we find that there's all sorts of things that matter. There's differences by occupation, there's differences by place, and there's also differences by the individual characteristics. So we find that the effect is much larger for high income occupations like doctors and lawyers, but it's also larger for sort of or middle income occupations that are skilled trades like brick masons and tailors. We also find that these patterns of transmission are sort of, they correlate, they're consistent with patterns of social connectedness in the area. Is that a question?
So are you looking at just single family streets with single family residences?
So at first, no, we're gonna have multifamily homes and everything with that. And then we do have some things where we restrict to single family homes. And then we do have things where we restrict, or we don't restrict, but we allow multifamily homes to potentially have a different effect. So, and we actually find larger things if it's someone in your same apartment building versus someone in the building next. Is that what you were getting at? Sorry, okay. Okay, so we find that these patterns of social connectedness really seem to correlate with the patterns of occupational transmission. Alex?
That notion of occupation you're using?
Okay, so we're using your self-reported occupation in the 1910 census. So that is either the occupation that you're working in or that you have at some point worked in. No, it's been aggregated. So we're using the aggregated versions that we have through IPUMs.
Like more aggregated with class.
Yeah.
Like if it's super the exact same thing, maybe they're really hiring you or something.
Yeah.
It's more broader, maybe.
Yeah, so we haven't ever done anything with the exact written titles that are provided. We have done a little bit of this aggregating up. So for example, it's like if you grew up next to a doctor, you're also more likely to go in the medical field. And so I think it sort of speaks a little bit to that, but we haven't done the exact title stuff. That'd be interesting to do. Yeah.
Sense of how stable these assignments are. I think like 1940 census asked like, where did you live 5 years before? And it's
Yeah.
10% of people change counties.
Yeah.
So probably that's like a lot of mobility here, so you have massive measurement.
Measurement error, I think in what? So we're measuring something with error, right? So in 1910, I think it's true that we're capturing a snapshot of who you're living next to. I mean, I have some existing work with Joe also that we find that even amongst natives in the United States during this time period, there's high levels of mobility between census waves. So we're going to think of this as a proxy for like where you're growing up, but it's for sure we're capturing a snapshot. And then you should think that your experience during childhood is exposed to those neighbors, but I don't know what the duration of that experience is, right? I also don't know if I should think of that as classical measurement error or not, but I think it seems reasonable that it might be. So maybe our estimates we should blow up our estimates a little bit from this. Okay. So we find that places that have stronger measures of social connection also tend to have stronger levels of occupational transmission. So if you think of places where the population is more homogeneous, so places where more people are born in state, or places that are more rural, for example, we see higher transmission. We also find that these effects decay with distance. So the effect of your next door neighbor is bigger than 2 doors down and 3 doors down and so forth. And then we find these really interesting patterns of homophily. So a boy is much more likely to adopt the occupation of a male next door neighbor than a female next door neighbor, and vice versa for girls. And similarly, if you're thinking of like immigrants, we find that children who are of Italian origin are much more likely to adopt the occupation of an Italian next door neighbor than they are of a German or a Russian next door neighbor. Okay, and I think probably the most important result is we find that this actually has real long-term economic consequences. So since we're just exploiting this highly localized variation, you might just think they're switching between similar skill and pay level occupations, but we actually find that there are sets of occupations that lead to significant changes in income and educational attainment, and that's true for both men and for women. And so being next to high income occupations like doctors and lawyers lead to increases in income relative to the other children who live next to you. But there's occupations like truck drivers and porters that actually lead to net reductions in income for those children relative to their neighbors. And it appears as though this is sort of driven by two different mechanisms. One, there's like a direct mechanism where you're more likely to go into that specific occupation. So if you live next to a high income person, you're more likely to go into that high income occupation. But also there seems to be this indirect spillover channel through educational attainment, where if you live next to a high income occupation, which often require high educational attainment, you're more likely to get more education, and that sort of opens more education doors. And we're going to show that it sort of leads to other high education, high paying occupations as well. Yeah.
Just in terms of framing it like that, so
yeah.
Wonder if do something showing place-based effects and then thinking about how much it's,
yeah. We talked about this a little bit, and Mike and I were like, do we have time to be able to do that before today? And we don't have it, but we would like to do that. It would be great. So that's on the to-do list. Thank you. Okay. Yeah, Dave.
Maybe, you said like, children living next to a doctor, but I'm wondering if it's really that the children living next to the doctor who has children, and it's not so much about the parental occupation as the interactions with the neighbor's children is.
Yeah, so we do find a little bit of this homophily. So if the family next door to you has kids that are the same ages, we do find elevated levels of transmission. That's clearly not everything that's going on here, but it's consistent with that you're more likely to interact with families who have similar age kids with you. And so I think what you're thinking is probably going on. Thank you. Okay, so how are we going to do this? We're going to use the historical full count US population census from 1910 to 1940. Essentially, we're going to start with all children between the ages of 5 and 18 in 1910. And so think of these as sort of, I'm going to think of them as young adults, since I would fall into this category now. Young adults in 1940. We're going to link them forward to 1940 using linkages from the census tree from the BYU Record Linking Lab. So essentially, if you're not familiar with this data, what it does is it uses a database of over 100 million hand-linked census records from a wiki-style genealogical website, Family Search. uses that as training data in a machine learning process to try and come up with predictive matches of possible linkages across census waves. And so using this method, we're able to get just like a vast number of matches, almost an order of magnitude more than many of the other historical linking methods. And so we're able to follow about half of the boys from 1910 to their 1940 outcomes. And I think this is really a big contribution of the paper. During the time period, lots of women, when they get married, they're going to change their last name. And so most historical record linking methods don't even attempt to follow women over time. But we're going to actually be able to observe what happens to a large number of these girls and think about what's the effect of neighbors on women's labor market outcomes.
Areas where the houses are pretty right next to each other, or?
No, not necessarily. So we actually find that the effects seem to be larger and more rural areas. But I should be very clear, we're excluding like farmers, where you might think of that as being very different. So I don't want you to think rural means that you live a mile away from your neighbor, but it's probably single family homes. That's where we see larger effects, but it does still show up in urban areas. Does that answer your question? Okay. Because obviously gendered patterns of labor force participation are very different during the time period. So we're going to do everything separately for boys and girls. We're going to be comparing boys to boys and girls to girls, but we are going to be presenting results for both of those groups. So just keep that in mind as we present these results of who's going to be in our counterfactual. Yeah, Jen.
Doctor, girl.
Yeah, so we don't have that specifically. So when we're looking at is your next door neighbor a doctor, we don't condition on gender. And so if it's a male doctor and you're a girl, we could look at that. We are going to subset the set of occupations we focus on to be the highest by population occupations for men and the highest by population occupations for women. So we'll look at them separately. So doctors, actually, we're not going to look at doctors for girls because there's very few female doctors during this time period. And we haven't done that cross, but we could do that. Of looking at if you grew up next to a doctor, how likely to become a nurse as a girl. Yeah.
There's only a
Yeah.
few.
Yeah.
They might be influenced by, get an next door neighbor who's a teacher and then become a teacher.
Yeah.
That's a possibility, but some other things are not.
Yeah. So we'll show you sort of what we see for the occupations for girls, and it sort of matches with what you're getting at. I think we're even further back where a lot of the women who are working in very low skilled occupations. And so we're getting people like showing up as milliners, hat makers and things like that, sort of in like low skilled work conditions. But I think we could look at sort of this cross interaction of do you end up working in complementary jobs to your high income, high education neighbor? And we haven't done that, but I think that would be interesting to do. Yeah. Yeah. No. Yeah. So we can show you a little bit of that, but by and large, that's not the case. So there are certain occupations where that is true. So miners tend to live next to each other, but that's because they live close to the mine. But by and large, most people within an occupation are the only person on their census sheet, so within their localized neighborhood. So it's not just that we have all the doctors and all the brick masons and the tailors clumping and living next to each other. Yeah, great question. That would be a problem for us. Yeah.
One neighbor in the doctor.
Yeah. Yep. So we are going to be able to sort of interact this with occupation characteristics to see what they go for, but that's all sort of getting baked into here, which is sort of, it makes it a little challenging to think about what is the counterfactual, right? And so we're going to think that you're exposed to two neighbors. We're going to say, basically, we're going to sort of do this as individual horse races. So let's think about, do you live next door to a doctor? How does that affect your probability of becoming a doctor relative to all the other occupations that your neighbor, the kids on your same street, are getting exposed to? And then we can do that occupation by occupation. And then we are going to try and find a way to try and sort of aggregate that up to get average effects. But it is sort of tricky because the counterfactual is the children on your street are being exposed to other occupations. And so we're sort of thinking about the counterfactual as the average occupation that the neighboring kids are being exposed to. And so actually in some of our results, so for example, if we find that an occupation leads to a decrease in income, that might actually be because you're no longer being exposed to someone in a good occupation that the neighboring kids on your street are being exposed to, right? Okay. Okay. So now that we have the set of children, we can link them forward to observe their outcomes. We need to identify sort of our treatment, our neighbors. In the historic census, about 35% of households are missing address information. So really what happens is there are some enumerators who just don't collect this address information. So then there's sort of this question of how can we actually reconstruct neighborhoods? So what we're going to do is we're going to be using the transcribed census enumeration order to identify who the neighbors are. So essentially, in 1910, census is enumerated by hand. They're given these very specific instructions that it's their duty to personally visit every family and farm within their district, and they're to canvass the block in order, not switching back and forth across the street. So they're actually shown, they're given this image in their information pamphlet, instructed that they should be going door to door. And so in theory, if an enumerator is doing what they've been instructed to do, we can just take the ordering of the enumeration and we should be able to observe who the neighbors are, okay? The question is, like, does this happen in practice? Okay, so what we're looking here on the right, this is a census enumeration sheet from 1910. So it's filled out by hand. This is in Illinois, in Cook County, looking at Chicago. At the very left-hand side, you probably can't see it, but written here vertically is the street name. And then you have house numbers. And then you have individual level information. So this is everything that we're going to observe for people for the census in 1910. Similarly for 1940. And essentially what's nice is because we do have this information, this address information in Chicago, we can do a little bit of check and see to what extent do people seem to be doing this. During the same time period, there's a company, the Sanborn Fire Insurance Company, who created these very detailed residential maps in certain cities. And so we're able to find places in the census that map to these or that correspond to these maps, and we can see, does the census enumerator look like they're doing what they were supposed to do? And you can see in this case, it looks like they are. Well, you probably can't see because it's too far away, but we're on Grace Street. This is Street 1206, or this is House 1206. They enumerate all of the families living there, followed by 1210, 1212, and then they just continue down the street, collecting the information on all of the households. And so this is a case that works really well for us. So this is obviously one case, but by and large, this does seem to capture what it's supposed to capture for us. So if we just take each of these households and use their ordering, we find that your order based on the census corresponds to how close your house numbers are for the subset of households where we have address information. And also we sort of see this monotonic decrease on the probability of you being on the same street as your ordering increases as well. So it seems like it's capturing what we want it to capture. There's obviously going to be some measurement error. Yeah. Okay, so
That's the urban issue.
yeah. Okay, so we can do a couple of things. So if you have a multifamily home, it's not clear what the enumerator did, right? Because sometimes they won't record even an apartment number. And so you have to decide, actually, is that helpful or is that hurt us if we're using the sheet ordering? If it seems likely that they're going to go apartment to apartment, so we're probably still capturing geographic proximity, but we don't know that for sure. Okay, so we can do a couple things. We can restrict the sample to single family homes and make sure that that's not causing a problem for us. But we can also say, let's just imagine everyone in your apartment building is your neighbor. And let's see if that effect is different from someone living in a different building. And we find that that effect is actually larger, which I think would be consistent with having closer relationships or closer interactions with those people. Does that answer your question? Okay. Okay, so yeah, we're not going to be naive about this. There's measurement error. There are enumerators who don't do what they're supposed to do. There's transcription errors as we go from the handwritten documents, the digital documents to the transcribed documents. We have families who weren't home when the numerator came around. So all these things are going to lead to error in our measurement of who your next door neighbor is. But by and large, we think that this measurement error is pretty negligible. So we take a random sampling of sheets that have a doctor on them, and we go back to those Sanborn fire insurance maps and we try and identify neighborhoods who have corresponding addresses and maps. And if we do a hand check, we find that 91% of the time, our definition of did you live next door to a doctor was accurate. So that's true for both the next door neighbors and the people who we said live further away. So in other words, the measurement that we're getting from the sheet ordering corresponds to the measurement that we would get if we had the actual addresses and the maps and we were able to go back and hand check, at least for this subsample. So we're going to think that measurement error is quite small. If you're worried about that, we can restrict to the subset of sheets where we have full address information, or we can do imputation processes and we end up finding similar effects. And so we don't really think measurement errors are things to worry about, but we can sort of do things to get at multifamily homes or other concerns that you might have. Okay. So what is our specification? What are we going to be doing? So I'm going to just think of a case study. We're going to look at doctors, but just remember that we're going to be doing this for a whole set of occupations. So essentially we have your ordering of the census. We see where you are. We have your sheet number, essentially the sheet that you're recorded on. So what we're going to do is we're just going to say, let's take each of those children. Let's look to see how likely they are to be a doctor in 1940. We're going to regress that on, did you have a doctor in your own household? So anyone in the household over the age of 18 in 1910, as well as was your next door neighbor, so either the household above you or the household below you, was someone in one of those households a doctor? We include age fixed effects just to account for sort of life cycle profile things. Remember, we have children who were between the ages of 5 and 18 in 1910. And then really the crux of our identification here, we're going to be including these census sheet fixed effects. Okay, so a census sheet, on average, it has about 8 households. So you can think what we're doing is we're making this comparison of people who live on the same census sheet. And we're saying, does the child who lived next door to the doctor, are they more likely to become a doctor relative to the children who were living just a little bit further away, but on the same census sheet and most likely on the same street? Okay. So once again, with this strategy, our identifying assumption is yes, there might be all sorts of residential sorting that's going on, but sort of conditional on appearing on the same census sheet, the sort of segment of a street. The occupation of your immediate next door neighbors is as good as randomly assigned. If you think of this theoretically, this seems plausible. So if a family, when they're going to buy a house, there's only limited housing supply, it's unpredictable which houses are going to be on the market. You have limited information about your potential neighbors and their occupations when you're looking for a home. And so you could imagine, it seems very plausible that people aren't sorting specifically on their neighbor's occupation. But there are ways that this could be violated. So imagine that children with a high propensity to choose a particular occupation, their families endogenously sort to live next to the occupation. That would be the type of problem that would exist for us. And that sounds sort of far-fetched, but you could imagine it sort of happening in a very simple way. Imagine you have a street where at one end you have some amenity like a park. If all of the wealthier families sort of sort and live next to each other on the nicer part of the street, the children in the wealthier families might be more likely to become doctors sort of for other reasons, but you might also be more likely to live next door to doctors, in which case we'd have sort of this correlation that is not representative of a causal impact. And so that's the type of thing that we worry about and that we want to try and figure out how important that is. Yeah. What placebo are you thinking of?
Oh, whether occupation might be don't neighbor, it's similar to mine.
Okay. Yeah, so let's actually we'll get to that. Okay, so what are we gonna do? Yeah, Nama.
Some of the variation is gonna be dip changes in the occupation of your neighbor, and some of it's gonna be whether your neighbor was employed or not. Can you look at the extensive margin? Would be particularly interesting for women, for example.
Yes. So we I do not have that here, but we do look at what happens for women. There are some occupations that lead to increases in employment for women. We actually, quite a while ago, we were sort of starting this in a separate vein of just thinking of, for girls, if you live next door to working women, does that affect your probability of working? But we're sort of too early. We're at a point in time where there are working women, but if you're a working woman, it's because of necessity, and they often are very low income and they all live in the same neighborhoods. So we don't really have variation in exposure to working women during this time period. Whereas if we were to move maybe 20 or 30 years later, we'd have more variation in where the working women live. Does that make sense? I think just for this identification strategy, that doesn't work very well.
I see, but on the men's, there's no extensive margin.
On the men, we don't see anything on the extensive margin. Okay, so how common is this type of sorting that would be problematic for us? So the first thing, coming back to this question before, we don't see bunching of occupations. It's not that all the doctors are living next door to each other and all the teachers are living next door to each other. Most people are the only person on their sheet that's in their occupation.
Can you say something about, like, if you're the first or the last on the sheet, like what happens to you? Like you feel like you want the other sheet to be there?
Yeah.
To give you
Yeah, that's right. So we're definitely like cutting things up pretty small, right? So one thing that we always do is if a family starts at the beginning of a sheet and continues down to the next one, we sort of pull the children over. So we're always thinking about the household heads sheet assignment. So we do take care of that. But you're right that you might imagine that your neighbor is also on the other sheet. So we can do a couple things. One, we can sort of include sheet placement fixed effects to make sure something there is not driving it. But we've done a little bit with this, but we're hesitant to go too far. You can imagine sort of pinning sheets together. But as soon as you start to do that, you start to lose this very high localized variation. So there's this trade-off of like, how much do I want to control for the selection into the neighborhood versus how much do I want to capture who your neighbors are? So I think by using the smaller sheets, we're sort of throwing away some of the variation in the cases that we could be using.
Use 8 neighboring. Right.
Yeah, that's true. Okay, so we could do that. We've actually done some when we've done sort of smaller numbers, sort of to get it robustness, but we could always expand it and think about people who live within 8 households of a doctor. We haven't done that. That's a good idea. Yeah, that's right. Yeah, that's right. Yeah, that's a really good point. Thank you, Janet.
They have more lines.
Yeah, that's right. Yeah.
Did that, sort of number of neighbors you might get out.
Yeah, number of households actually would.
Because it varies across.
Yeah, that's a great point. So we do some of that where I'll show you, I think on this slide, I talk about it. I don't have it here. We could show you later in the appendix, but we do it for within 3 households of the doctor. But we could expand that to go a little bit further. Okay. Okay, so we don't find sort of this within occupation sorting, but we also find minimal within sheet sorting. So I think to the point earlier, you could imagine that it's like the lawyers are sorting to live next door to the doctors. On average, if we look at the household head characteristics of people who live next door to, say, a doctor and people who live a little bit further away on the same sheet, we end up finding that they look quite similar. They're not identical. There are differences, and some of them are statistically significant, in part because we have these large samples, but they're really not economically significant. And it's very clear that they're not selected in the same way that their doctor neighbor is selected. So they're not nearly as high income, things like that. So it doesn't seem like we just have this sorting in the way that you were imagining. There was another hand. Oh yeah. Oh.
Obviously, this is kind of great for your strategy, but I'm curious, like, why do you think this is true? Like, is someone like surprising? Is it something to do with the housing stock? There's like big houses and small houses. Like, why do you think this is relatively?
Why do we think which thing is true? Why do we think that there's not as much sorting?
Blocks and a mixture.
Yeah, I mean, so we'll I'll show you a little bit of this for doctors. So there's definitely sorting that's going on, but I think essentially once you zoom in on focusing on within 8 households, there's not really a difference in the housing amenities that you're being exposed to, and so that's why we don't observe all of this bunching that's going on. So it's true that high income people live next door to doctors, but it's not true that it's all the doctors that are living next door to each other. Or, sorry, and when I say next door, like within the same 8 houses of doctors.
Does this work mainly when the rank of my neighbors is higher than my own parents? Or think about this.
Yeah. So I'll show you in just a minute. We find effects across occupations, so it's not just upward or downward. It's bigger for upward occupations. We haven't. I don't think we have, Mike. Remind me if I'm wrong. We haven't looked at the interaction of like if your parents are in a low income occupation, your neighbors in a. Now we kind of have done a little bit with that. So we end up finding. I don't want to speak too much on that. Sorry, I'll have to come back to it. But we haven't done the complete interaction. It's intergenerational transmission is very high. So it's not that you're like shifting away from your own parents' occupation that much. But we haven't looked at like if your parents were low income and your neighbor's high income, are you more likely to shift than if you're high and high? Something. Okay. Another thing that we're going to do is we can say, well, let's take everything that we observe about you in the 1910 census and your family, and let's just throw it into a lasso model and try and predict how likely are you to go into each of these occupations. And we end up finding that the next door neighbors and people who live a little bit further away have pretty similar predicted probabilities of going into the focal neighbor's occupation. So if we take all of the observable things, we just don't really find differences between these local neighbors in their probability of going into those occupations. So it seems like there is some sorting. We think it's minimal. There's ways that we can try and address that, but it doesn't seem like it's really that important. So we can control for these household characteristics. We can narrow that bandwidth to within 3 households. And then we can even sort of as like a control function style, we can control for those last of predicted probabilities, and we end up finding pretty similar things. Okay, so let's get to results. Any questions before we do that? Okay, so what we're gonna do, we're first gonna just present this for boys growing up next door to doctors, and then we can move on to a whole range of occupations and see what happens to girls as well. So in the first column, this is basically just OLS. We're gonna look at all of the boys in the 1910 census that we can link forward to 1940. And we're just gonna regress this on, do you have a doctor in your own household, and do you have a doctor next door? Having a doctor in your own household is associated with about a 10 percentage point increase in the probability of being a doctor. So very large. We're not going to interpret that as causal, but there's strong intergenerational transmission. But also growing up next door to a doctor is associated with a 0.7 percentage point increase in the probability of being a doctor. So once again, this is no fixed effects. So this is basically growing up next door to a doctor relative to all of the other boys. So all of the residential sorting is sort of being fed into this. So once we start to restrict to people who live close to doctors on the same sheet, and then include these geographic fixed effects. So actually in this one, we're using bigger fixed effects, so it sort of gets it like that pinning of sheets together. But as we start to do that with our preferred specification with the sheet fixed effects, we find that growing up next door to a doctor in 1910 is associated with a 0.3 percentage point increase in the probability of being a doctor in 1940 relative to the other boys who were growing up on your same census sheet. So how big is that? We can go, and for the boys who are on the same census sheet but live further than 1 door away from the doctor, we can calculate what's your likelihood of being a doctor in 1940. That's 0.78%. And so this would suggest that growing up next door to a doctor increases your probability of being a doctor by about 40% relative to other boys that were in your same neighborhood. Alex, was that? Okay. Okay. So this is what we see for doctors. We can essentially then replicate this and just switch it out for any occupation that we're interested in. So what we're going to do is we're going to look at the top 25 occupations in terms of employment for men, top 25 for women. In the paper, we can extend this. We'd look at the top 50 for men. For women, it doesn't make as much sense as we've already talked about. Their occupation or their employment is very concentrated in several occupations. But we find interesting patterns. So here I'm plotting for you the own household coefficient on the left-hand panel and the next door neighbor coefficient in the right-hand panel, both of them scaled by the untreated mean for each occupation. And then they're ordered or they're sorted based on the size of this coefficient, okay? So I don't know if you can read this, but essentially what do we see? We're seeing that across all of the large occupations for boys, there's a significant amount of within household transmission. Boys are very likely to adopt the occupation of someone in their own household, and these effects are large for some occupations. What we're really interested in is this right-hand panel, looking at the next door neighbor coefficient, where we see that there are occupations like brick masons, tailors, doctors, blacksmiths, and barbers that significantly increase the probability of a child going into the occupation relative to other boys that were growing up on their same street.
It'd be interesting to link this to housing stability. I don't necessarily think brick mason would be particularly likely to stay in the same place for a long time.
Yeah.
But going back to the exposure question we had.
Yeah.
A doctor maybe live in the same place.
Yeah, that's okay. So we've struggled so much with how can we get at the duration of exposure, which I think is what you're also getting at. And we'd love to link you back and forward in the census and see, but the problem is if we don't have your address, we don't like, we can link you forward and we can link the doctor forward perhaps, but we can't link, like, we don't link everyone. So we sort of have these correlated these interactive probabilities. And so it becomes unlikely, but I like your idea of maybe we could identify occupations that are stable and see if occupations that are stable have higher transmission effects. That'd be a good idea. Okay, so this is just the 25 largest occupations in terms of employment for men. We can do the same thing for women. And, oh yeah, listen.
Thinking of Anna's point about risk probability.
Yeah.
This in terms of, what's the likelihood you change occupations to go from, let's say, your dad
Yeah.
neighbor, if your neighbor makes more money, or it's like in a higher prestige occupation.
Yeah.
You're probably not gonna have doctors' kids super influenced by the barbers, but you might have barbers that
Influenced by the doctors. Yeah. So, like I said, we've done something sort of like that. We don't quite have that. we have something I'll show at the end that might get at this, which is essentially the full occupation by occupation matrix. And so you can sort of see the degree to which people are shifting in and out of certain occupations. But I don't quite have that of like, if your parent was low income, what happens if you live next door to a doctor? And is the opposite true? No, we can do that. And so we'll show you by occupation characteristics, but it's sort of the interaction of my own parents' occupation and my neighbor's occupation. And I feel like we actually do have that somewhere a long time ago. We'll have to talk about it. Maybe it wasn't interesting. Okay, yes, I mean. Yeah. So this is scaled. This is scaled by the untreated probability. So this is scaled by the probability that people who lived further away were going into that occupation. So essentially, I'm taking this coefficient and scaling it by the untreated mean for each of those occupations separately. And so this is telling us the percent change in the probability of becoming a brick mason, almost 60%, relative to the other kids' probability of becoming a brick mason on your same street.
And are the own effects?
The own effects are also scaled as well. Yeah.
Yeah.
They're also scaled. Yeah. Okay. Yeah. Jacob?
So you've already done so much in this paper, but I'm kind of thinking about translating this to like occupation scores, and it'd be interesting to see like the gap between.
Yeah. Well, yeah. So let me get to something I think speaks to that. Okay. Okay. Yep. Hillary.
Just, it's a visual thing, you have to be ordering.
I know.
Same.
Yeah.
Gives you another.
Okay.
Piece of comparison.
Yeah. We've struggled to know which way to sort this, but
Yeah.
maybe sort it the same, at least within them, ranking by this one and then doing that. Okay, thank you. Okay, if we look at what happens for women, we see high within household transmission of occupation. We see there's some occupations that lead to transmission, like private laundresses, musicians, and teachers. But by and large, we don't really see effects going on for women here. Sort of just quickly revisiting identification. If we were to switch out our outcome and think about the predicted lasso probabilities, that's sort of the light blue bar here. So if we put that as the outcome, we don't see that your next door neighbor is predictive of your predicted probability as much as you realize. And if we control for that, it doesn't really change our estimates here. Okay, so what we want to do next, yeah.
The husband's occupation for women. Like that's
Yeah. Yeah, so that's where we're wanting to go next. So we have some stuff that's sort of going to speak a little bit to that, and so we'd like to take that, but we're not sure how that's going to fit into this paper necessarily, but it's a great idea for the future. Okay, so I have about 4 minutes, so I'm going to just really quickly highlight what we're going to do here. So we're going to basically take each of these data sets for all these occupations, stack them up, and interact our fixed effects with occupation fixed effects. So we're exploiting the same within sheet occupation, looking at each, or within sheet variation, looking at each occupation, and then getting some weighted average of this beta 1 so that we can think about the average effect. But then also we can look at subsets, or we could interact this with occupation or person characteristics and think about what is it about the neighbor that's making this transmissible. We end up finding on average that living next door to someone in a particular occupation changes your probability of going into that occupation by about 0.3 percentage points or 10%. For women, it's 0.1 percentage points and about 6.5%. So that's on average. But what we're really interested in is thinking about this heterogeneity and trying to get at potential mechanisms. So sort of the first thing is if we take that same stack specification and have your next, do you live next door to a doctor, but also do you 2 doors down, 3 doors down, 4 doors down, and so forth, we see this monotonic decrease. So geographic proximity seems to be really important, where we see larger transmission effects the closer you live to that neighbor. We also find that neighborhoods that are more connected, so rural neighborhoods or neighborhoods that have low out-of-state shares, have higher levels of transmission. And when your neighbor has the same characteristic as you, we see higher levels of transmission. So if you share the same birthplace, if your families have the same aged kids, we see slightly higher transmission. And then once again, these patterns of homophily. So boys are much more likely to adopt occupation of male neighbors than female neighbors, and vice versa for girls. And I think it's really interesting. So these patterns of heterogeneity, they really match patterns of social connectedness. So we don't have Facebook or LinkedIn during the time period. So it's hard to measure social connection. So we're going to proxy for this by looking at the rate at which neighboring children from different groups marry each other. And we end up finding that these patterns correlate very closely. So the rate at which boys and girls who live next door marry each other is high, and then it falls as sort of the distance increases. But then also we see the same gaps as we had in the transmission of occupations. So neighbors in rural neighborhoods or neighboring kids in rural neighborhoods are more likely to marry, but also in the bottom panel, by your own individual characteristics. So if you have the same birthplace or the same birthplace state, if you have children of the same age in your families, or if you're of the same race. So really, we think that this suggests that there's an important sort of social connectedness story and mechanism at play here, leading children to adopt occupations that they see of adults in their neighborhood. So we also find this variation by occupation. So high income occupations are highly transmissible. I wish we had this interacted with your own parents' occupation. So we'll have to pull that out and we'll have to tell you what that looks like. But sort of going on this, we want to then see, does this actually have economic consequences? And we find that it does. So we can look to see, does this affect income and earnings? Yeah. Yeah. So we've tried to figure out how to do that. The problem is we have a snapshot. We have you at an age, but we don't know when you started getting exposed, and we don't know when you ended getting exposed. So it's not clear how to interpret that. So we don't really have that. Okay, so what we're going to do is we're going to have the same occupation by occupation regression. We're just going to change the outcome to be your income in 1940 and your educational attainment. And we end up finding that it matters. So for girls, growing up next to people in certain occupations lead to increases in income. And these increases are meaningful, so 7 to 9% relative to average annual earnings of all women for some of these occupations at the very top. But there's clearly occupations where if you grow up next to private laundresses and laborers, we see reductions in earnings. This is own earnings. This is not spousal earnings. And so we could similarly look at that. And I think given sort of what we saw with marriage, it seems reasonable to do that. I think importantly, we see changes in educational attainment for women as well. And I think this has potential intergenerational consequences. We see similar things for men. So there are occupations that lead to increases in income for men. And some of these income increases are quite large. But there's also occupations that lead to income decreases relative to what their peers are experiencing. And same with educational attainment. And so I just want to end with this last thing. If we sort of do the full cross of occupation by occupation, we see there are certain occupations, high education occupations in this corner, that lead to increased transmission to its own occupation, sort of along the diagonal, but also into other high education occupations. And so there's sort of this direct channel of it makes you more likely to be a doctor, to live next door to a doctor, but it also makes you more likely to go into other highly educated occupations because you go on to get more education. So I am out of time. So I'll just close with sort of this last point. We find that childhood neighbors really are influential on your future income and education through your occupation choice. We might think people don't talk to their neighbors anymore. So why does this matter? But I think it's important to realize maybe there are other parent or adult-child interactions in communities today, and they could be really important for influencing children's later life outcomes. And that's all. Thank you.
Wait, so.
Okay, great. We'll get started shortly. Okay, thank you, everyone. Today, we're talking about the life cycle effects of childhood Medicaid expansions over adulthood. And as you can see, there are several of us co-authors on this project, and we have a great attendance rate at this conference today. So I put everybody's pictures to make sure that they get credit for their work, but they can also stand up, and you can see that they're in the room, and you can talk to all of us. So Zoe Chopra and Atul Gupta and Rebecca McKibben and Kevin Rins are all here, and David Wasser from the Census is joining us online. And also Itai Lurie from the Treasury has been such an important friend of this project, meeting with us routinely on the project. So we thank him for his work on the project too. So we're at the children's meeting and not a health meeting. So let's just step back and talk about Medicaid. So Medicaid is the health insurance program for low-income people. And a little known fact is now Medicaid actually has more people enrolled than Medicare, the program for the elderly. That has happened in recent years. So we're going to be focusing on Medicaid for kids. And actually, kids represent a large fraction of people on Medicaid. So out of the 75.7 million people that are enrolled in Medicaid, 36 million of them are children. But the finding that is even perhaps more striking is that 49% of US children are enrolled in Medicaid. So when we're thinking about the impacts of Medicaid on children, we're not thinking about the impact of some niche program. We're thinking about a program that affects almost 50% of kids. We're going to estimate the effects of childhood Medicaid eligibility by comparing cohorts and states across time, focusing on people born in January 1981 through December of 1984. And this strategy, of course, has a long precedent, starting with Janet Curry and John Gruber's work, their twin papers in 1996. And then Janet gave the Ely lecture at now the AEA Distinguished Lecture at the annual meetings of the American Economic Association, and said, really, there needs to be some more impact on the long-term impact of interventions for kids. And then lo and behold, many years later, there are now several papers that look at the long-term impact of Medicaid and health insurance programs for kids. And I'm going to be just focusing on this one in the lower left, the one with David Brown and Itai Lurie and myself. And we are going to revisit the identification strategy in that paper. There we were using data from the US Treasury, which we no longer have access to, but we're going to look at the longer run impact using 10 more years of data and using data from the US Census as opposed to the US Treasury. So, but before we move on to the current work, I just want to review what we found in that paper. So by age 28, Medicaid eligibles live longer. They have increased college enrollment. They have lower fertility through age 28. They have higher lifetime earnings. And then the headline finding was that Medicaid partly pays for itself. It generates an additional 58 cents of federal tax revenue per dollar spent, and that's discounted back to birth. So Medicaid was partially paying for itself to age 28. And so the big question is Medicaid going to pay for itself completely when we follow these children for an additional 10 years? What's the rate of return on investment? There's been a lot of press coverage on Medicaid. Medicaid's been in the news a lot lately. It was in the news a lot when we were finding that Medicaid partially paid for itself. But I think one thing to focus on here for the children's meeting is that I think One of the biggest ramifications of the work in this literature, the work by my co-authors and myself, and also the other people in the literature, is that when Nathan Hundred and Ben Sprung-Kaiser looked at all of the things that the government does, they found that the things that have the highest marginal value of public funds, the highest MVPF, are things that invest in children through their health and education. And so you can see that I've just highlighted that portion of the abstract showing that investments in children's health and education are some of the highest marginal value of public fund things that the US government does. And then I've highlighted up here, they had a bunch of different studies showing the marginal value of public funds. And this is the result from Brown, Kowalski, and Lurie showing that Medicaid partially pays for itself. Knowing that a public program can partially pay for itself is of course important for policy. So the findings have been featured in the economic report of the president. But also there are some interesting implications for thinking about congressional scoring of new legislation. So traditionally there's a 10-year budget window that's used for congressional scoring. But the CBO met with a subset of us, the Congressional Budget Office met with a subset of us and said, you know, it's interesting that if investments in children's health and education are some of the highest marginal value things that the government does, it's interesting that we can only score those out for 10 years when you wouldn't necessarily expect the government to recoup their investments over just that 10-year period. And so there were researchers at the CBO who were thinking about, well, what can we do? So they tried to take estimates from our work and from other work and just apply a constant increase in tax revenue up to future years. But then the question is like, well, actually, is the magnitude of the coefficient going to change over time? What if you add another 10 years? What if you moved beyond that? Would you find increasing returns? Would they stay the same? And so that's really where we're going to focus our efforts on today. So what do another 10 years reveal? So it turns out, thanks to Rebecca for putting together this slide, but we found at the beginning was really only the tip of the iceberg. So looking through age 28, we had seen that there were reductions in fertility for Medicaid eligibilities, for Medicaid eligibles, but those declines in family formation, declines in fertility, and declines in marriage, they start to turn around at around age 28, and they have partially reversed. They don't catch up, but they've definitely reversed, and you'll see those coefficients. The gains in mortality persist, and the earnings and tax gains accelerate, which is important, and that's better than what we would have predicted if we had just applied a constant rate over time. So with that, I'm going to turn it over to my co-author Atul Gupta, who will talk more about the specific things that we do in this paper.
Thanks, Amanda. Good morning, everyone. It's an honor and privilege to share the stage with Amanda and to present this work at Children and Families. So I'm very excited. So I'll get started by talking about our research design. As Amanda said, we follow individuals born in 4 birth cohorts from 1981 through 1984. And we can follow them through age 38. So even our oldest cohort, we can follow them through age 38. And the treatment that we're interested in is a number of years that they were eligible for Medicaid. So what we're going to do is we're going to infer or calculate eligibility for these kids when these individuals were kids from ages 0 through 18. And we're going to add that, and that continuously varying measure is going to be our measure of treatment. And then when we look at outcomes, we're going to estimate the effects on various outcomes, as Amanda said, family formation, mortality, economic outcomes, separately at each age in adulthood. And I'll talk a lot more about that. We're very proud of the data that we've been able to put together in this project. It's taken a long time. We access data through the US Census Bureau. And so it's administrative data that we can use to infer Medicaid eligibility for these kids. We can look at marriage and fertility using the information that's recorded on the tax returns. We observe date of death in the numerant that comes from the Social Security Administration. And then for economic outcomes, we rely on the tax information that's available in the census, but through a couple of different ways. So earnings, so wages, we can see directly from the W-2 form. So that's just something we observe directly. For earned income credit and income tax, we actually have to estimate it using TaxSim because that information is not reported in the census. But we've actually been able to get access to some new data that recently arrived in the census and it's available for research, which they refer to as enhanced tax data. So I'll talk about that here. So this data, it's only available for a subset of years starting in 2010. And what that means for our cohorts is that we can observe this for individuals ages 30 to 38. The nice thing about this enhanced tax data that we believe we're one of the first external projects that's been able to use this information in the census, but it has a lot of promise for research going forward, is that you can observe a number of important deductions like the home mortgage interest deduction, local and state taxes, medical spending, these kinds of itemized deductions, which make a big difference in actually estimating your tax payments. And so we believe that that's actually been very instrumental in allowing us to estimate tax payments and earned income tax credit much more accurately than if you did not have access to this. We run it through TaxSim, which is a tax simulation software that's actually been maintained by the NBER. And that predicts their income tax liability and their earned income credit. And sort of a taste of whether this has been accurate or not, we think this has actually worked out quite well. So I don't think we have we do have a clicker. Yeah. So this series over here, these are the actual average tax payments recorded in the treasury data, which were used in Amanda's previous paper, which I'll just refer to as BKL, over these ages from 19 through 28. And then this blue series, these are the average values of the estimated tax payments in our census data from ages 30 to 38. And unfortunately, age 29, we can't observe tax payments in either series. And we think the means line up pretty nicely. So that's a good sign that this is working out pretty well. In terms of estimating the spending on these children by Medicaid, we use data from NSYS, which is a standard administrative data source. So you can observe enrollment in Medicaid and spending. I'll talk more about how we use this to arrive at the program cost. So our treatment is number of years of Medicaid eligibility. So for that, first we have to calculate Medicaid eligibility. As I said, in the census, we observe, through the tax information, we observe the income, the household income, family size, and then the state in which these kids are living. We can apply the Medicaid eligibility criteria and thresholds that are applicable to these children in the years that they're living in those states. And we can do this by year for each birth cohort because sometimes the Medicaid eligibility criteria also depend on your birth year. And using that approach, we can actually infer eligibility for these children in every age from 0 to 18. We can add that up, and that sort of continuously varying measure is the number of years of Medicaid eligibility from 0 through 18. Obviously, this measure of eligibility depends on state generosity and variation in state policies, but it also varies. It also reflects household circumstances and perhaps individual circumstances, which may be correlated with their future outcomes. And so that's the reason why instead of using the actual eligibility, what we want to use is the simulated eligibility measure, which was pioneered by Janet and John Gruber in their 1996 paper, and then also used subsequently in BKL. So the idea of simulated eligibility is we take a fixed national sample of kids. So this is a randomly drawn sample, so it's representative in terms of geography, gender, and so on. And we also stratify it by birth cohort. So so each birth cohort contributes 25% of the sample. And then we essentially run the sample through each state's Medicaid rules in each calendar year and also by each birth cohort. And that allows us to sort of generate the total number of simulated eligibility years for each birth cohort and each year. Yeah.
So, that family size tax data?
Yes.
So are you using like the number of claimers?
Yeah, the number of individuals that are claimed on the tax. Yeah.
Okay, is that pretty, I guess one question is the accuracy of that per family size. The second is that what Medicaid rules correspond to, like tax claiming or a broader concept.
Right. So, there could be potential for some measurement error, of course. I mean, that's the best data that we have available to us in the census.
Like, link them to the decennial or ACS, be able to see 2000.
Okay. Yeah. So that's, I think we did do, so Kevin is probably somewhere here in this, in the room. I think we did do we did do an exercise where we checked how much we're missing by comparing it to, I think, a subset for whom we had better information. And I think it was looking pretty good. And then the other question you had about Medicaid eligibility, perhaps depending on other things beyond these. So we've done a robustness check where we also use the CPS to sort of come up with this Medicaid eligibility measure, because in the CPS you have much richer information about the household characteristics, for example, disability and other things. And the results are pretty similar when we use that measure of eligibility.
A similar question on the same thing, and that comes down to, particularly in the early part of your period, there's not going to be very high tax filing rates for a lot of Medicaid eligible population.
I see.
So it's good to see that there's a high correlation with the CPS.
Right.
But that's something, and there's not the claiming, Kevin, right? Doesn't show up till 1994, the dependent claiming. I see, but you observe the number of dependents.
Yeah, we observe the number of claim dependents, we don't do the day.
Yeah. Yeah.
So this is to give you a sense of what the variation in the simulated eligibility looks like, and that's sort of inherent in our design. So on the left-hand side, this heat map shows the average number of years of simulated eligibility by state. And the sort of lighter the shade, the lower is the number of years of simulated eligibility. So you can see that for the cohort that was born in January of 1981, in most states the average years of simulated eligibility was between 1 and 4 years. But when you fast forward to the cohort that was born in December 1984, the map has become a lot darker. And so in most states, the number of years of simulated eligibility for these kids is between 4 and 6. And when you take the average difference, so between these two cohorts, the number of years of simulated eligibility went up by about 1.85. And so that's a nice descriptive statistic to keep in mind, not only because it gives a sense of the increase in Medicaid generosity over this period, but it's also something that can be used to scale our estimates. So all our estimates are going to have this flavor that they represent the effect for an additional year of simulated eligibility. But if you're looking for something to scale it by in terms of what's the sort of average effect over this period, multiplying it by 1.85 or approximately by 2 would be a good way to think about it. Yeah.
Sometimes targeted young kids and sometimes we're incumbents. So it's going to affect the differences in when they were exposed to childhood.
Yes. Yes.
So,
That's
6 versus the exposed teenager.
Yeah. No, that is unfortunately we don't have that result for you today, but that's high on our to-do list, and that's exactly something that we're thinking about. So we want to stratify our sample based on your age at first exposure to Medicaid. And yeah, I mean, we also expect that there's probably some interesting and important heterogeneity on that dimension. Okay, so now that we have our simulated eligibility measured, this is to give you a sense of the regressions that we're going to run. So our outcome, let's say mortality for individual I, and we're going to do this at each age of adulthood. So A is going to be a function of this continuously varying measure, which is the total years of simulated Medicaid eligibility, which is going to vary by your birth cohort and your state of birth. And we'll include state of birth fixed effects, birth cohort fixed effects. So birth cohort is month by year. So January 1981 is one birth cohort, for example. And we're going to run this regression separately at each age, obviously for each outcome. And we're going to cluster our standard errors by the state of birth. Because we're thinking that's essentially the sort of level of treatment in this design. So you might be wondering why I talked about a reduced form regression. So It turns out when you run the first stage, simulated eligibility is highly correlated with actual eligibility. So an additional year of simulated eligibility predicts an increase of 0.94 years of actual eligibility. It's very precisely estimated, and the first stage F-stat is 172. And so we decided that it's actually, it's sort of easier to think about this just in the reduced form as an intent to treat effect of what happens when you make Medicaid coverage more generous. Okay, so let's look at the results. So we'll begin with thinking about family formation. And so the first outcome we look at is fertility. Amanda had mentioned that through age 28, you see this decline in fertility. Well, it turns out that that decline reverses itself almost exactly at that age that the previous paper stopped at, and it doesn't fully reverse itself, but it goes about 50%. There's a 50% decrease. I'm going to show you a lot of figures that look like this. So let me take some time to just explain this one, and hopefully that'll help interpret the ones that are going to come later. So on the x-axis, we're going to show the effects at different ages. And each of these estimates is from a different regression, as I said earlier, because we estimate the effect at each age separately. The dashed lines are the confidence intervals. On the y-axis is the effect in absolute terms. So in this case, for fertility, it's how many individuals are parents per 10,000 people. This measure of fertility is an extensive margin. So it's are you a parent or not? We're also now going to run. I don't have those results right now. We want to run also total fertility. So look at that margin as well. And then this legend over here talks about the significance of the point estimates. In most cases, the point estimates are significant at either the 5% or lower, but there are a few situations where they're not, and I'll point those out. And then we also mention the point estimate at ages 28 and 38, just as a point of comparison against the mean values. So sorry, yeah. Oh, that's a great idea. Yeah.
Just looks from your figure, like mostly we're just cutting out teen births here, which you might think of as a good.
Right.
Yeah.
And just a delay in the later births.
And a delay in the later births,
Right.
exactly, which could also be a good thing,
Yeah.
so.
Yeah, no, that's a fantastic idea. We should do that. So that was in absolute terms. Here we're just dividing it against the mean at each age and showing you the relative effect. So, to your point, there's a very large decline in the probability of having a child in the teenage years. And, as you saw earlier, since the effect is getting smaller and the mean is getting larger, the relative effect is kind of asymptotating towards zero. We also wanted to see how this varies for men and women. So interestingly, the peak decline in the late 20s is much larger for women than it is for men. But they kind of end up at the same place in terms of the absolute decline in fertility. So by age 38, men and women have a similar decline in the probability of being a parent. And even in relative terms, it's quite similar. We look at marriage.
For the men.
Yeah.
Arguing fertility for men, is that in the same household census or?
Yeah, so we observe on the tax return, basically, so that's how we do it. So we look at marriage, and marriage follows a very similar pattern. That's not surprising, but it's still interesting to see that in the late 20s was when the peak decline in marriage occurred, and then it kind of reverses itself. And in terms of estimates, it's actually quite similar. It's a 4% decline by age 28, which by age 38. And if you remember, the effects are very similar on fertility as well.
You want to be careful because if there's a change in the likelihood that they're living in a household with their kid,
Yes.
you're confident.
Yes. Yeah, that's one. No, that's true. That's a limitation of the data that we have, that we can only see them as parents if they are on the tax return. Yes.
So you're interpreting it basically as social.
Mhm.
healthier, it actually increase your fertility. If infertility is a measure of poor health,
Right.
I mean, I don't know. Right.
Right. No, that's certainly an interesting question. I mean, these are obviously net effects, and for some individuals, there could be. It's possible that health insurance actually improves your probability of having kids. I'm not sure if we can get at it in our data. I think one thing that would help, Janet's earlier point about looking at teenage pregnancies, if it turns out that most of the decline is actually coming from teenage pregnancies, I think then we can say something stronger. Yeah.
But also Medicaid gives you access to contraception.
Exactly. Yeah. So again, we can look at this by men and women separately. In this case, the effects are quite similar in absolute terms, though in relative terms, the effects are slightly larger for men in terms of the decline by age 38. Although this might be one of those things where men might actually go to the same level if we had a few more years. They might end up at the same place. And even in relative terms, the decline in marriage is larger for men. Okay, so next we wanted to look at mortality. Yes.
Being plain, same house.
Yes, I think in principle we could look at how many partners you're, again, subject to this caveat that it's based on how you are claimed on the tax form. We could look at a number of different measures related to marriage. But what did you have in mind? Yeah. Yeah.
So it'd be interesting to see if there is a household.
Oh yeah, that's a great idea. Yeah, we could look at how stable the household is, like how long the same parents live with the same kids. Yeah. Yeah, that's a great idea. Yeah. Yes.
And you for any of these particular points, like a lot of these papers, there's usually you look at like one of the age cut outcomes, and you can get like a pre-trend on people who turn that age maybe before the reforms. I don't know how the timing of like reforms and measurement aligns here, but I think for some of the outcomes, mortality, you can see any of those.
So one thing that we have done, I don't think we show it here, is for wages. I mean, it's not a placebo necessarily, but for wages, we see that the effects are essentially zero at very young ages, and they only start building up later in the 20s. But I don't think we can do this in this cohort, but maybe in some other cohorts, we could bring in just for the purposes of showing that there's no effect because they weren't necessarily exposed to some of these reforms. Yeah, thanks.
Or like you can imagine if you have immigrants during the same time period who aren't eligible for Medicaid, you wouldn't expect to see the same changes, marriages for us.
Why not?
If they're not eligible.
Oh, if they're not eligible.
That's not eligible.
Yes.
Expansion shouldn't affect that. Sort of to get this idea of having placebo or
right.
I don't know if that's true.
Right. So we do have foreign-born children in our sample.
Yeah. To do it on a state by state basis, and also to Tara's point about funding things like contraception, I think, Medicaid has been used to fund clinics that then serve everybody.
Right, so a lot of immigrants now go to clinics that get most of their funding from Medicaid, even if Medicaid doesn't pay for that particular person. Same with school health.
I see. So one thing I will say, generally speaking, on this this point about placebo or points getting identification, later on we're going to show that we find larger effects for individuals that were in lower income families than individuals who are in higher income families. And so you see this dose response, which kind of nicely lines up with the exposure to Medicaid. And I think that's quite helpful, although I'm sure that, there are other things that we could push on. Okay, so next we wanted to look at mortality. So it turns out that the mortality decline that we saw in the previous paper, so that's this dashed line at age 28. So there was a decline of 3 fewer deaths per 10,000 people. That sort of, it seems to linearly kind of grow. And by age 38, it's up to about 8 fewer deaths per 10,000 people. If you prefer looking at it in proportional terms, it's quite flat. So, it's about 3.5 to 4% decline at age 28. It's a similar sort of decline at age 38, 10 years later. I think a more interesting thing is how it looks for men and women. It turns out that the absolute decline is larger for men, but men also die at a much higher rate in this age group, unfortunately. And so, it's even though that they have a much larger decline, in relative terms, actually, they have a smaller improvement than women. So unfortunately, in the census, we don't see the cause of death because the Social Security Administration doesn't need to know the cause of death. But if we would love to, if there are ideas about how we could see something about cause of death, we're all ears. And then later on, we're going to use our results to get at or to sort of come up with an estimate of the cost per life saved from Medicaid and how that changes between ages 28 and 38. And so that is something that's quite interesting. Okay, so we'll turn over now to the economic outcomes. So we first look at W2, the earnings that are recorded in the W2. So as Amanda said, you see this increase in wages and it really seems to take off in the 30s. So it's quite convex. At age 28, we have an estimate of about $1,500 on a base of $104,000. So that's about 1.4%. By age 38, it's up to $12,000 on a much larger base, of course. But even in relative terms, it goes up. So in relative terms, it was about 1.4% at age 28. By age 38, it's well over 2%. It's 2.3%. And here I just wanted to double click on one thing that Amanda had said earlier. The CBO, they put out these reports where they're trying to estimate the long run effects of Medicaid, which is always a difficult task. And so it's not clear what assumption to use on the long run effects of Medicaid, right? Do you hold it fixed or do you allow it to change over time? Unfortunately, there's not that much evidence to talk about whether there is a change dynamically. And so something that they've done in the past is they just hold it fixed. So incidentally, in the latest CBO report, they actually they used a figure of 1.5% increase in earnings due to Medicaid, and they just held that fixed all the way through age 65. But our results here suggest that that might actually be an underestimate. And we don't know if these trends continue, but it seems like it could be well over 1.5% in the 40s. Again, we can compare men and women. So interestingly, the effects are much larger for women. Yeah.
So that basically shows you thought of permanent income as your concept, which sounds like, then they show how income at different ages underestimates lifetime.
Right.
So this might line up nicely with that.
Oh yeah, that's a good idea actually. So yeah, I can ask you later about exactly what they did. So coming back to this, so the effects are much larger for women, both in absolute terms and since women on average have slightly lower earnings, in relative terms, actually women the effect on their earnings is twice as large as it is for men. The effects for men are actually not even statistically significant until the early 30s. So that's actually yes.
So everything's here cumulative.
Yes.
Okay, so I'm a little confused by your mean there.
Oh yeah, sorry.
Is there a reason why you decided to show it cumulatively rather than age by age? Just because we have a natural sort of interpretation of the gain in earnings at a given age and, you know, what the shape of the profile looks like. So I was just curious. I mean, obviously it's there.
Yeah, I mean, so that, the derivative is sort of the, no, I mean, just, I guess just for brevity, we kind of focused on these. These were a little bit smoother than the contemporaneous age by age, which tend to be a little bit more jumpy. But in the paper, for sure, we'll include both. Yeah. Thanks. Okay, and then finally, we separated the earnings from the taxes and transfers because, as I said earlier, the earnings we can observe directly in the census, but then the taxes and the earned income credit is something that we estimate using tax-in. So just to make that distinction, yes.
So I think that could also help you with mortality, because then you can look at kind of.
Yes, they
Slower with occupations and see if that, like, driving your mortality. Yes.
That would be awesome. I know that, so for a subset of these individuals, we can also see them in the ACS. And so for those individuals, for sure, we can see their occupations. And we're actually using the ACS to look at education outcomes. I will say we've run into some troubles with disclosing results using the ACS. So I don't know. Is the answer there? But yes, I think that would be one way to maybe get at this, differences not only in mortality but also potentially in earnings. Yeah, yeah. Okay. Oh yes.
The increases in wages and
Coming from fertility. Oh yeah, yeah. We could. Yeah, I think that we could definitely do. Yeah, that's a great idea. We that'll help put some context on this. Okay, so we'll first look at the effect on earned income credit, and sort of continuing what we saw in the previous paper that Amanda did. You see this decline in earned income credit, realized earned income credit for individuals. All of these results are going to be limited from age 30 to 38 because we observe this enhanced tax data. Again, it's cumulative. And you see that it kind of increases pretty steeply as they age. And one thing to think about earned income credit is it is quite dependent on how many kids you have. So since we've seen that they have a decline in fertility and an increase in earnings, it's not surprising that there's a decline in earned income credit. In relative terms, it increases slightly over time, but it's not. I wouldn't say it's a very noticeable increase. Again, the distinction between women and men is quite large. So women have a much larger decline in earned income credit than men, both in absolute and in relative terms, despite the fact that the average earned income credit receipt is actually larger for women to begin with. And again, this might make more sense. I think, again, with the decline in fertility, for example, that I showed you earlier, is much larger for women than it is for men. Okay, and then the last outcome that we're going to look at is the effect on the federal tax payments through age 38. Again, these are estimated tax payments put out by TaxSim. Yes. Yes.
kids. We'll all have 2 kids by that age. I don't know if you can help them tease apart how much is due to fertility versus.
I mean, we can certainly we observe how many kids they have by a certain age. So we could certainly stratify it on that basis. I'll have to think a little bit more about whether we can interpret that as the effect of fertility or not. But yeah, I think it's an interesting suggestion to explore for sure. Okay, so yeah, so there's this increase we see this increase in tax payments from age 30 to 38. And in case you're wondering why, it's so low at age 30, that's because that's the first year we observe tax payments. So that's why cumulative tax payments are only $5,000 at that age. But you see this rapid increase. And as a result, it's also increasing in relative terms. So it goes up from about 3% at age 28 to about 5% at age 38, although, the confidence intervals are such that, perhaps they may not be necessarily different between those ages. In terms of the differences between men and women, here actually we see that in relative terms, the effects are much larger for women, as you would expect, given that the effect on earnings was much larger, the effect on earned income credit was much larger. In absolute terms, we do see a larger effect on tax payments among men, but because the denominator is also much larger, in relative terms, it turns out to be smaller. I think I saw that hand first, and then I'll come to you. Yeah. Oh, that's a great question. We had this discussion at some point. We've gone back and forth on this. I think the answer is
Oh, people who are dead don't pay taxes.
yes.
So if you're keeping people alive longer and if each person is paying more taxes, because you're eventually going to put an NCF, so I want to make sure you get all the credits.
So the people who are not alive are in this. They're not paying any taxes.
Yes.
And someone is filing taxes directly the spouse. Spouses are three cohorts. How is that being shown here? Is it the cumulative household?
Yeah, these are household tax. These are household tax payments.
Also,
Yes. I think, and so I was going to come to this point about, we see if you notice these increases in tax payments, it's much steeper, for example, than the increase in wages. And there could be several reasons for that. One could be the progressivity of the tax schedule. I think another reason could be household formation and the spouse that they end up marrying. So that's something that we've thought about maybe pushing on, but it's not something that we have for you today. Yeah. Okay. So this, so those were the sort of main set of results. And, now I just want, in the last 5 minutes that I have, I just wanted to go through maybe a little bit of robustness checks, the dose response that I spoke about earlier, and then just tying it up to talk about the return on investment from Medicaid and also the cost per life saved. So I'll begin by talking about this dose response. So, one question you might have is, are the effects bigger for individuals who are in lower income families who may have been exposed more to Medicaid than those who are in higher income families? So a simple exercise we can do is we can stratify the sample based on the quartile of their household income when these individuals were kids and exposed to Medicaid. And so, we do it by 4 quantiles. What we expect to see essentially is, individuals who had a larger increase in eligibility, you would expect that they would have a bigger effect. And so that's sort of this idea of dose response. So I'm going to show a lot of figures. I won't necessarily go through every one, but we do this for every outcome. So, on the x-axis, I'm going to plot the first stage effect. So that's the effect of a year of simulated eligibility on a year of actual eligibility. And then on the y-axis, we're going to plot the reduced form effect that we see for these individuals relative to the mean, because the means are quite different between these 4 groups. And so this is, here the outcome is fertility. Now, the first thing that you'll see on the x-axis is actually, so the Q4 are the individuals in the richest families. So the first stage for them is much smaller. That makes sense. There's not, you wouldn't expect them to receive an increase in Medicaid eligibility. The next one is actually Q1. So that's, first we were quite surprised by this. But then, if you think about this time period, these Medicaid expansions are in the 80s and 90s. And so it wasn't really targeted at the lowest income households. Those expansions were more in the 60s and 70s. And so actually the biggest effects on Medicaid eligibility are for kids who are in the middle to income groups. And then, as you saw earlier, the net effect on fertility is a negative effect. And so you see that the most negative effect is for the kids in these 2 income groups. So in the interest of time, since I only have 2 minutes, I won't necessarily go through all of these, but essentially all of these figures follow this kind of pattern. We also do this robustness check. We do a couple of robustness checks where one of them is we recalculate our eligibility using the CPS. The CPS has much richer information, which allows you to get at Medicaid eligibility much more accurately than what we can see in the census data. And then the other one is, in our baseline, we have state fixed effects and birth cohort fixed effects separately. But in this one, what we do is we interact state fixed effects with calendar years. So we allow each state to have its own fixed effects. And even that kind of flexible specification doesn't really do much to our estimates. So that reassures us that this is not driven by differential trends across states. Okay, so I'm sure a question that's on your mind is does Medicaid pay for itself? So here, one of the limitations we had is since we only observe the tax payments from ages 30 to 38, we have to rely, also on what was already estimated in the previous paper. So we use that, and then we add to that the new estimates that we have from ages 30 to 38, and then we use these two together to arrive at a return per dollar of Medicaid cost. I wouldn't say these estimates are final because we have this problem of age 29 being omitted, but I think you'll see that it won't matter that much. So the estimate from the previous paper was 58%, so that's 0.58. And this dashed line is the cost of Medicaid. And you'll see that when you start adding the discounted tax payments by these individuals, it goes well past 1 in basically the early 30s. So it eventually won't end up mattering that much what we do with age 29, but I just don't have an answer on the exact age yet. And then in terms of the cost per life saved, we can do a simple calculation. Our discounted Medicaid cost is $299 per child. This is discounted back to birth using a 3% discount rate. And then the lives per saved was 8 per 10,000, which I'd shown you guys earlier. So if you just divide this by this, you get a cost per life saved average of $375,000 approximately. That's much lower than any statistical value of life. And that's it. So in the last 15 seconds, I'll just wrap up. So it turns out that adding 10 years of data really helps reveal some parts of the story which are quite important. First of all, there are these non-linearities in family formation. There's a reversal of the decline in fertility and marriage. Mortality effects are quite stable. The cost per life saved drops quite a bit. And then the economic returns really accelerate. So, using a fixed effect on earnings tends to underestimate the benefits of Medicaid. And it turns out that the fiscal returns are multiples of the cost of Medicaid by the time they reach 38. Thank you.
Okay, I want to thank the organizers for including this paper on the program. We're very excited to share this research with you and get some feedback. Adam is in the room back there. He can stand up for a second. And John Eric and Ioana, I feel like I can't be outstaged by the previous talk. And John Eric and Ioana are probably connecting online. So this paper is going to be thinking about the connection between field of study or college major and future fertility. And as probably many of you know, there has been a drastic decline in fertility rates globally with profound implications for how society is structured. And there's lots of questions about what are the inputs or what are the things that might be driving this. And if you think about the kinds of the drivers that most people talk about, income, occupational flexibility, partners, a lot of that is driven also by education. So one of the things I didn't know before starting this project is that there are enormous gradients across fields or college majors with fertility. So this figure shows by age the probability of being a parent in Sweden from 20 to 45. And what you might see, what surprised me first of all was, if you look at completed fertility, the difference between kind of education, health fields and science fields is about 13 percentage points. The other thing you might notice is that there's a lot of lines crossing between 25 and 35. And so the field of study that you have seems to be correlated not just with how many children you have, but also the timing of children. Okay, so those are the two kind of elements that we're going to be wanting to think about. And so when we think about why do we see this gradient, of course, there might be elements of family background, the size of the family you grew up in, your ability, your preferences. There might be anticipated constraints, so you might only apply to if you know you want to have children, you might apply to majors where they might be more family friendly. And then once we think about just changing a field of study, that's going to be possibly a direct effect. So for example, maybe a student in my class might learn about the motherhood penalty and say, oh, I don't know if I want to, it might change their future decisions. But very likely it has a lot to do with labor market opportunities, the flexibility of the jobs they might be in, and the family formation, the partners they're going to be with, and peers. So I'm not going to be able to say too much about peers today, but I'm going to have some suggestive evidence about the other two elements. So what do we want to answer today, or what's the research questions? First is going to be, are these, at least in my opinion, enormous gradients across field, are they causal or are they mostly explained by selection? And the second is to think about, how we can look at this variation across fields to get at mechanisms, okay? And this can connect nicely with the literature on income effects or greedy or inflexible work, what role that might have. And also think about, partners, do they step in? Are they helpful? Do they bring in resources, right? When you switch these fields. So how are we going to do this? We're going to do this in Sweden, and we're going to, probably already anticipating, we're going to link college admissions data to birth, household composition, labor market registers. And in Sweden, the way you apply for college is at the national level, and it's cleared at the national level. So you in your application, you list 12 programs. And that's kind of great for us because we can then look at people close to the different thresholds for different programs and compare women and men that are just above the threshold to just below the threshold and look at that variation of moving someone across that threshold. Now, this empirical design has been used, to look at labor market outcomes and sort of mating. And so what we'll do in the papers, we'll find just a quick preview. I know it's been a long week for all of us. We're going to find significant changes, of course, in income. It's kind of consistent with the literature. We'll also find that for women. And we'll also see some results on schedule regularity across fields, and those kind of go aligned with what you might expect. What we do see is that in terms of timing, we see some fields either bring fertility forward, they actually have children earlier, and some other fields delay the transition to motherhood. And they're the kind of fields that you would expect. So public sector fields, tend to, if you get across the threshold to get into a public sector, into a field that leads to a public sector job, you tend to have children earlier. If you go in, if you cross into a field with, oh, sorry, I was talking about regularity, wasn't I? Oh, no, I was talking about the timing. Yeah. And if you cross into a field that's more demanding jobs, then you tend to delay childhood. What's interesting is we don't find very much in terms of completed fertility. Okay. Except for one exception, which I will talk about a little bit, but medicine. So doctors have more kids. We think this is something specific to the Swedish context. So doctors are public sector workers, and they have very strong unions, so they have very good benefits. We can talk about that more, but we think that's it's something specific to Sweden. There's a large literature written by many people in this room looking at education level and fertility, looking at changes in the compulsory schooling laws or other kinds of secondary, tertiary reforms. In general, they don't find effects on fertility. There is a literature looking at these associations, demonstrating what I just showed you, that there's this large gradient between fields and fertility. There's a recent paper by Chris Campos and co-authors, which is very nice, looking at trying to explain gender gaps in income, and they do look at changes in fertility across fields. They're using Chilean data, and unfortunately, they don't have completed fertility. But I definitely want to make a shout out to that paper. And then there's, of course, a recent literature on college activity and elite programs. And then I added this yesterday after the talk in the morning. There is a literature on income effects, and most of those don't show that there really aren't large effects on fertility. So the one that's kind of relevant for our context in Sweden, looking at lotteries, getting large income from that, no effects on fertility in the paper as we saw yesterday, unconditional cash transfers. Okay, so just a little bit, probably many of you are aware about these institutional details, but I think having seen some of the talks, it's good just to reinforce how different Sweden is from the US. So back in 1974, they started having very generous parental leave. It's about 450 days per child, okay? And that was increased to 480 days in 2002. It's shared between the parents, but in practice, the fathers didn't take very much of this parental leave. And that started changing when they started changing the laws, where in the mid-1990s, sorry, in 1995, there was like 1 month that was assigned to each parent. And so if a parent didn't take that 1 month leave, then they lost it, okay? And that was increased to 2 months in 2002 and 3 months in 2016. And that dramatically changed the share of the paid leave that fathers took, from about 10% of parental leave in mid-1990s to 32% in 2024. Now, of course, childcare is highly subsidized in Sweden, universal, highly utilized. It's almost automatic that the women come off the parental leave, they go back to work, and they put their children into childcare. And compulsory schooling and healthcare, of course, free of charge in Sweden as well. And the tertiary education in Sweden is tuition free and public, okay? And they additionally can get some grants for cost of living, and you can also kind of boost that with loans if you want. And the thing that's going to be beneficial for us is that the application process is centralized across the entire country. So students have an opportunity to list 12 programs, so they can say like Uppsala economics, Stockholm law, okay? And they can, but in general, they don't list all 12, okay? And admission is by different admission groups, mostly by GPA and a Swedish version of the SAT score, okay? So the way it works is that each program has so many seats allocated to kind of GPA preference and so many seats allocated to SAT preference. And so the person with the highest GPA gets their first choice of program. The person with the second highest GPA gets, if it's still available, they get their first choice, if not the second choice, and so on. And this creates implicit thresholds, okay? One thing to point out about this design, with this setting, which is a bit different from the typical RDD, is that people know their score. They don't know the threshold. They don't know the cutoff, because the cutoff is what's uncertain, okay? But they do have some information about the history of cutoff. So they have like a rough idea, but they don't know exactly what it is. So we're going to link the application records to the education registers. We have about 1.1 million pair observations across 53,000 admissions cutoffs. I could show you 53,000 different point estimates. That would be extremely noisy. That would be pretty boring. So what we need to do is to group them in some way. And so we group them into 14 fields. And we separate kind of the long and short fields. So you can think about like BA versus associates, okay? And then from that, we can link those to medical birth registry, labor market earnings, occupation, partners, and conscription tests for the men. The one thing that I want to say that I think we're not exactly, it's not ideal, but our occupational information is going to come from ONET, which is based on occupations in the US, and we're going to be linking that to the Swedish data. So there's only 2 results using that, but maybe we take that with a grain of salt, okay? We're trying to get some Swedish, well, we have some Swedish surveys that we're trying to use to get the equivalent of that. Okay, the empirical strategy is going to be an RDD, but there's a lot of often confusion about how this works. Like, you have these applications, how do you get these pairs, okay? So there's a few steps that you go through when you from the full application to getting the pairs at the end. Okay, so this is completely made up. This is not an actual application, but imagine there's a student and made the scores go from 0 to 10. And they list like engineering, medicine, economics, politics, and teaching. Okay, with these cutoffs. So because their score is 8, then they get admitted into economics. Okay. And so the first thing that we do when we try to think about what's the relevant pairs that we want to compare, first of all, we remove the dominated programs. Okay, so for example, medicine has a cutoff threshold 10. If the person had a score above or at 10, they would go into they would get admitted to engineering and they would never get to medicine, right? So we remove that application. And then what we do is we merge the groups that we talked about. So economics and politics, it would be in social sciences. And we end up with a list of engineering, social sciences second, and teaching as third. Okay. And so the comparisons we want to do is we want to see people above and just above and below the threshold. So we can look at like the pair engineering and social sciences. In that case, that this individual is below the threshold, and that can enter an RDD for that pair. And then for social sciences and teaching, that's another pair where this particular application is above the threshold. Okay, and we will have application, we'll cluster center respective application. Yeah.
I know about the college applications, does the student have an idea about what sort of study she wants to do? Like social sciences is one thing.
Yeah.
Like somebody who wants to list economics as a field of study would not list medicine as a field of study.
I agree this is an artificial example. I'll show you actual application data in a second. Yeah.
One thing just about lumping social sciences together, there's very different wages for, say, economics versus sociology, but it's not clear to me it makes sense to lump those together.
I agree with you on that. Yeah. So we're kind of using standard classifications for the groups that used in literature, and I think we want to think carefully about how we could extend this. But maybe we can get to at the end talk. This is what I have for today. Yeah.
There was an article in the Wall Street Journal that's the decline of sociology, the other quoting starting salaries, which were very low.
Yeah.
Social science.
Yeah. We could split that out. Yeah. I think there's I think at the end I would like to talk a little bit about some ideas that we have about how we form these groups. Okay, so actually here we go. This is what an actual applications look like. So you're absolutely correct. This on the left hand side, you see, sorry. On the left hand side, there we go. We kind of group this by kind of health fields, science fields, social science fields, education, humanities, and also kind of the color coding is that way. And you can see that medicine, their second best, the next best is often health or engineering or science. Those are like the top things, which it kind of makes sense. And then for health, it's like short health and engineering and science. And once you get to these short programs, then they tend to apply to other things as well. The same thing for, and I'll 1 second. For engineering science, you see that the green dominate. For here, you start to see the blue and the purple dominate. And then once you get to kind of education, humanities, you start to see kind of the grays dominate here. So the applications seem to make sense, and the comparisons are going to be those comparisons. Actually, so this is what they put on the application. I'm also going to show you kind of for compliers what the actual comparisons we're going to be making are when we do the estimates. Yeah. Yeah. We're going that direction. That's why I was trying to thank you. So you would end up with, what you could put like quintiles of income or kind of, flexibility, irregularity, or you could do different things like that. And I think we're trying to think about what is the optimal way for doing this, because you could, okay, now I'm going to give you my spiel for the end of the talk, but you could imagine if you could think about making pairs that when you go across the threshold, move income but not job, job demands, or going across the threshold does not change income but does change the job demands, right? And that, I think that's kind of where we want to go with this. Yeah. Yeah, no. I agree. I think that's where we're going. Okay, so this is a relatively straightforward RDD, except for that we have 40 years of data, and various admissions programs changing over time. So we have we basically standardize all these different admission scores, okay, to basically be able to stack all the applications across this entire period. And then so we have an indicator for if you're above or below the threshold. And then we allow the slopes to vary based on the selectivities of the programs, basically, and also the priority you give to the program. We can talk about this more, but we spent a lot of time talking, sorry, I'm going away from the microphone, thinking about it. So the applicants are going to be all applicants between 1977 and 2005, aged less than 23 and no children in the year before applying. I think one of the novelties of what's novel about the data is that we actually have applications going back to 1977. So we actually have variation of field that we can follow people for like 40 plus years. Okay, yeah. Yeah. It'll be one slide. There was, yeah. Yeah, no, it's okay. It's okay. The dynamics, I think, is really interesting. I think it's also kind of relatively new. So give me just 2 slides and we'll talk about that. So this is what college admission and accepting admission looks like. So of course, if you're below the threshold, you can't be admitted and accepted. And about 40% of people accept the admissions that they're assigned. Okay. We don't use this because there's non-compliance. So there's other ways to get in beyond the admission. I was told a funny story where in the old days, it used to be that in the very first lecture, they would see how many students were in the classroom and determine how many remaining open seats were, and they would pull people off the waiting list that way. And that would not be within this admissions data. So if we look at enrollment after 5 years, you can see that above the threshold, the number of people enrolling is not that different from the initial admissions in the same term, but you see quite a bit of non-compliance here. Okay, so this is going to be our treatment. Is going to be the enrollment after 5 years. So what does that look like, and why did we choose 5 years? So this blue line is telling us enrolling in the same field. So this is like the first stage in the same term as your application. And you can see this goes down because then people get in other ways, or they reapply the next year. Okay. This is for enrolling in, oh shoot. This is for enrolling in any field. Okay. And this is for getting a degree. Okay. And you can see one thing that was a bit maybe somewhat comforting is that most of the margin of crossing that threshold is not really pushing people to get a degree per se, but it's really the intensive margin that it's driving. Okay, because the effect on getting any degrees is quite small. Okay. And so this is a very new graph that we just recently made to give you an idea of what are the compliers doing in reality. Okay. And so what we do is we estimate at 5 years after application, what are the things that you actually do if you're below the threshold, right? So the yellow here now is new from relative to the other figure, because these are the people who either reapply or find some other way to get into that field. You can see that the color scheme of the alternatives are pretty similar to what we saw before. Okay, but there are some people within the compliers, again, the small, but that don't enroll in these shorter programs. Okay. So this is the first stage for each of the fields that we're going to be looking at. I'm going to be showing lots of figures like this. So each of these is an estimate of for example, crossing the threshold into engineering versus all other alternatives. Okay. And so for engineering and medicine, it's quite high. It's like in the upper 20s, 30%. For humanities and STEM short, it's quite small, about 5%. These are quite noisy and never significant, and they really blow up all of our figures. And so we're going to be dropping these from the results that we show. Yeah.
Is it because there's differences in the availability of seats in these different?
Absolutely. Yeah. So engineering and medicine and law, I think those are those are the highest. Those are very competitive and they have very limited seats. Yeah. And so it's not that you can just wait a year and maybe apply to a less competitive program. People do like, for example, medicine do wait and try to reapply again. But it's very limited. Yeah. Yeah. Oh yeah.
That's suggesting that if you don't get into engineering, you're more likely to just not go to college.
No. So if this is for enrolling, so here you can see if you don't get into engineering, so about 30% of the people who don't get in initially, they go later, and then they go into other fields like health, a shorter engineering degree, or science, and so on. But the point the point we wanted to make here is that almost everyone, it's really the intensive margin that'll be driving our results. Not
In the
yeah.
program.
This enrollment in the program. Oh, sorry. Yeah. So this is enrollment in the program that you initially applied to. Do you enroll in it within 5 years? Yeah. Yeah. The answer is absolutely yes. There's just a huge headache. And I have to say, like, Adam spent so much time on this, trying to understand these codes, and because there's different admission systems. So we really do our best. We do a lot of work where we look at people who apply and then look at their enrollment, because those codes are different, and then see that we can get consistent kinds of degrees. I'm not sure what the other thing that is, yeah, there's a question of should we be looking at this entire period altogether? So for example, one thing that's kind of surprised me is that law degrees in Sweden were not competitive, were not really like a big thing in the 80s, and then they kind of blew up later. So there are some changes over time happening, if that's kind of what you, yeah. Okay, so I'm going to go through this kind of quickly because I kind of want to get to the results, but because people don't see the cutoff, it's kind of hard to imagine how they would bunch per se. But you do see that people, because they roughly know what the cutoff is, that these and because I'm choosing people based on the pairs based on where they get admitted, that it kind of peaks at the cutoff value. For most variables, we see a pretty good balance. Ninth grade GPA is probably the closest thing to the admission score that we have in the data, and that's quite good. We have a little bit of a disagreement, imbalance in non-cognitive skills for men, and then in birth year. And I think we can still work on our empirical strategy to improve this, but these are quite economically small values. Okay, so for labor market outcomes, so again, each of these is the two-stage least squares estimate, where we look at the reduced form and divide it by the first stage that we looked at earlier. And this is the increase in your annual earnings in thousands of Swedish kroner. And I think this kind of follows the literature and most of our expectations. So medicine, engineering, business, law get the highest returns. Getting over the threshold into education, into kind of humanities, or like social science associate degrees lead to a negative income effects. Okay. So let's talk about fertility then. So what we're going to do is I'm going to look at every 5 years after the application, so 5 years, 10 years, 25 years, and so on, across the fields. Okay, and then we'll zoom in on a few fields and show the dynamics. Okay, so each point is going to be the two-stage least squares estimate. And so here you can see the education leads to accelerated fertility. So they're having children earlier if they're across the threshold, but we don't see much else going on except for maybe social sciences. Maybe this is the economists there. So they seem to be delaying fertility relative to if they had not crossed the threshold. So the way to interpret this is that, yeah, the probability, the increase in probability that your parent 5 years after application goes up about 6%. Yeah. Pardon me? Yes. Yeah. So for now, we're first going to look at the fertility results, and then I'll talk about the suggestive results I have on assortative mating and these kinds of things. Yeah. And so what's interesting is after 10 years, you start to see, one second, you start to see some timing changes where a lot of the fields that you would study that would lead to public sector jobs are fields where you actually start having children earlier. Okay, so things like medicine, education, health, and so on. And the places where you start to see, we see a bit of a delay are in social sciences and business science. And then we can kind of go through this. What's interesting is that as you go further along or further forward from the application, then we see less and less of changes between these by crossing the threshold. And by 25 years after application, we see that medicine is actually still having more likely to be a parent after 25 years, and we see some imprecise negative effects in like business and law, engineering. And then we can look at the number of children, and basically the results are very similar. I'm skipping ahead to year 10. Okay, again, we had public sector are having more children, and social science and business are having fewer children. And when we look at completed fertility, we don't see too much except for maybe this estimate fell short, and then again with medicine. So this is for women. Now let's think about the fertility dynamics for both men and women and what's happening. So each of these points is looking at each year after application and getting the RDD estimate and what is the effect on the fertility. Oh, sorry, and actually there's a few questions. Maybe I'll take a pause now. Yeah. Actually, I think Heather had a question in the back. Yeah.
Start looking for about having when I exit my degree with them. That would be part of the, I was just thinking about whether you thought that would work. I know probably as you go out further, those effects small, but closer to the completion of your.
Yeah, and that's one of the reasons we split the long and short degrees, because we thought that we didn't want to mix those things up. And when we go through these figures, it's actually super clear that, especially for the women, that you can see here for medicine, they basically have almost a very precise 0, and then it jumps up, which it corresponds to the end of their training. For men, it's not so precisely 0 until the graduation, but that's definitely part of the story. Yeah, yeah.
How many part of work is so like the actual number? I don't know what like 0.1 versus minus 0.1.
So 0.1 here means that you're 10 percentage points more likely to be a parent. The mean 0.25. So it's quite a bit. So 0.25 additional. No, this is no. This is I thought you were asking how many more children. It's 0.25 additional children, a quarter of a child. Yeah. And this estimate is telling you the change in the probability of being a parent at that age. So it's roughly 10% early, and in the long run, it's a bit like 8% more likely to be a parent. Yeah, yeah.
So for both of these and the previous ones, are you following the same cohorts over time, or are you sort of having to chop up cohorts to get further out. So I just wondering, is this like, are there compositional changes that are contributing to this, or is this the same people over the lifetime?
We have almost everyone to completed fertility.
Oh,
Yeah. So maybe there's a few years at the end where we don't see them, between 20 and 25. But there's not much going on there. So yeah. Now there could be compositional changes across time because of things we talked about earlier, these programs changing and things. Yeah. But but there's nothing in terms of these figures. Yeah.
Right, but now we see this timing, it's almost like if you had decided to say we did it for both of us 20 years out or even 2 years out, we might have seen effects. And so I think that like trailing off what's going on is notable to know. Is that something weird in data and composition, or is it actually these women are having children at that age, or like I think that seems like an important thing given the headline result that we know.
Yeah, no, absolutely. So we can extend it. We haven't. So typically women are applying most of them are over 20 years old when they apply. So 25 would imply that they're about 45. So we just interpreted that as like at that point they're basically completing fertility. But we could extend it to see what happens.
Great. And are women really having a lot of kids? I mean, maybe they are having kids between 43 and 45, like ages that the thing. So I guess I want to know if you're not look back to your headline at 25 years, not look back at 22 years.
Okay.
Right?
Yes.
You see what I'm getting?
I see what you're getting. So your question is this these last 3 points like compositional effects and yeah, we can look into that. Yeah. Thank you. Yeah. Was there another? So it's interesting here that the men and women kind of follow the same pattern. So each of these points, I think maybe hopefully we know what the points mean now. What's clear is there's a very clear pattern for women that they finish their degrees and then they start to have children. There is anecdotal evidence from talking to doctors in Sweden that it's a status thing to have children. So as soon as they finish their training, they start trying to have kids. They get married and start having kids. And that's, I think, kind of explains this kind of very dramatic increase immediately after they're having children. So again, I think there's something special about doctors. I think there might be a nice case study here to look at to see what's really happening. This is for educational short programs. You see again some of the public sector job where there's this increase, and then kind of gradually the people who were below the threshold gradually catch up in the long run. Now, if we look at non-public sector, if we look at fields that typically lead to private sector jobs, now we start seeing differences. Okay, so for example, in business, we see women actually tend to delay fertility. Okay, but then they eventually catch up. Okay, you don't see the same for men. If anything, you see maybe a little bit of an increase for men. But again, the people below the admission thresholds tend to catch up there as well. And something similar for engineering. Okay. No. Okay. Yeah. It looks very similar. It looks very similar also for oops. That's number of children. Okay, so I think there's questions about mechanisms, what's happening here. I think probably many of us expected that some of these more demanding jobs would lead to lower fertility. So I'm going to show you some very suggestive figures. I don't want to push too hard on them, but I think they tell a nice story. We're going to be looking at income. We're going to be looking at whether a field leads you to be a job that's has a less regular schedule. And then we'll be looking at the partners, what's happening with the partners in terms of like how much income resources they add to the household, and also how do they contribute in terms of paid parental leave. Yeah.
So this same RD used to look at whether they go to like one of the colleges or not. Did you see if like going to the college, access to networks, things like that actually get worse fertility?
There's actually a nice paper on that in restudy. Yeah, we could replicate their results. Yeah, and we haven't done that, but we could. I can show you something very quickly about sorting with the fields that we have if there's time. Okay, so what we're gonna do here is we're gonna show the causal effect on the number of children on the y-axis, okay, and then the causal effect that we get for on income for going into a field, okay, and basically just doing kind of a scatter plots to see if we see correlations. Again, this is suggestive, okay, but what we see here, and again, because I think I'm also making comparisons with the US, and the health sector is quite different in Sweden compared to the US. So I'm going to show correlations with and without the health sector. Yeah. And so what you see is maybe a little bit of a negative correlation, especially if you take out this outlier of medicine, where fields that have higher causal effects in terms of income have lower fertility effects. Again, this is this is at 10 years after application. If we look at 25 years after application, if you know medicine, it does not seem to be much of an association between the causal effect on income and being a parent across these fields. Again, I think this is kind of consistent with the paper we saw yesterday. When you have these exogenous shocks to your income, it doesn't seem to change fertility. We can look, yeah, sure. Yeah.
Yeah, maybe I'm just slow. Isn't this the opposite of what you're doing? You've got more income, makes you more likely to go left.
Yeah, exactly. Yes, so I think what's driving this is the job conditions. I think it's not, yeah. So I think the next one I think is maybe the one that you're interested in. Again, I want to again say we're using ONET data here, so this is not perfect. But yeah.
Years and they have kind of steady, but then the earnings pick up later. And so I just wonder whether when we look at income as a kind of static or average over time, if that's in that moment, I just wonder whether that's part of the validity this is part of the problem. Frankly, capital investments across the applications and you're looking at different life cycle profiles. And whether that's part of the story that I think is a little bit muddled in this picture that there might be more to do here, I guess.
Definitely agree with that. This is income, the effect on income at 10 years after application, so it's at the same time. So it is, but again, it is suggestive, but I wouldn't say that we can come to conclusions. So I think there's some things that we can do that again suggested by Heather, where we can look at different groupings that change the margins differently that we're going towards. Yeah. I have 5 minutes, but I think I'm doing okay, so I can take more questions.
Impact of who the women are partners.
That's coming. That's coming. Because it's a bit different. Yeah. Yes, well, that's coming. Let's look at one dimension of like the demands of the job, or how flexible they are. So here, maybe partially inspired by Jana's talk a few days ago, showing that women have high willingness to pay to avoid this kind of schedule irregularity. Here we see that going into these more demanding fields, such as business science, social science, engineering, lead to less regular schedules. And this is, again, something that Jana highlighted, something that women were willing to avoid. And then things like education and health and medicine, where we're giving you more regular schedules. Again, this is, ONET data applied to the Swedish context. So, but I think the correlation here we find is pretty striking. So in these less flexible fields, okay, we see that women delay more and in more flexible or more rate, sorry, I should say, more regular scheduled fields, then that's when the women who are actually having children earlier. So that's when they change the timing. And then if we look at completed fertility, we still see a negative correlation here. So it seems like there's still something going on if we look at, you know, whether the the conditions are not ideal in terms of this scheduling irregularity. There is a negative correlation with fertility, which kind of leads to the question of, well, that's nice, but then why do we in the end don't see much of an effect for many of these demanding jobs? And so that's where we get to the partners in the last few minutes, okay? So one of the things we'll look at here is, so if a woman crosses the threshold, then we follow them and ask, what is the salary of their partners when they're 40, 45, okay? And what's interesting here is the woman going into these more demanding jobs, jobs that lead to higher income, we see a sort of mating here in terms of income, where, so just so you understand, the circles are the effects that we saw already. This is the effect on income for women. And the squares are the effect on the partner's income. Okay, so this is kind of the associated sort of mating story in terms of income. Okay, so women who go cross the threshold into medicine, engineering, business, law, and science, maybe not science, but their partners have higher income. So that's bringing even more resources into the household. It's interesting that for these for the fields on the left, we don't see much in terms of the partners. There doesn't seem to be the same kind of a sort of mating. And since someone asked, we do see this is a likelihood that your partner is in the same field. And it seems to be a complete gender share story. So on the left-hand side, engineering is dominated by men. So the likelihood of a woman to be with a partner who's also an engineer gets causally increased by 20%. On the left-hand side, we see that men that go into education and health, they're more likely to partner with women in education and health. But we don't see much else in terms of terms. And now, of course, if we looked at the elite programs, or if we looked at very specific programs, not just general fields, but you know, Stockholm University, Uppsala University, this would likely change. Okay, and that's kind of Magna and co-author's paper. Okay, and I think this is the last result on partners, which I found quite striking. So this is, okay, so we look at the first, we follow women to their first child, okay? Then we look at the number of days of leave they take in the year before, the year of the child, and the year after the child, okay? And that's gonna be the outcome, and that those are the circles. Okay, what we see for the women is that when they're in these more demanding fields, okay, they're in the private sector, they actually end up taking less leave. Okay, in terms about 15 to 20 days less. But what's interesting in the Swedish context is that you see that the men are compensating. Okay, especially for women who are in social science, business, engineering, they're compensating for this and actually spending more leave time than men. And this might be part of the story of why we don't find any effects on completed fertility. Again, medicine is a bit of an outlier there, but okay, so that's all I have to show for today. I have like 3 seconds left. But in terms of like what's driving these effects on fertility, we do kind of confirm that there's this negative correlation, at least with, you know, the demands of the job. But at least in the Swedish context, it seems that when women are demanding jobs, the men are actually compensating in a way. We'll get more measures of that beyond just parental leave. Thank you.
We also, we have linked fees here, you know, everybody, so what do you even box you for is this like, it's a lot, because you can look at the fees. The cash, they use for it.
Okay.
So you can look at it, you still add alternatives. That's all good, that's that, they could have put it in the. Right, okay.
Yeah.
And finally, like.
Başlıyor ama hala sonuçta ben kaç tane izlese de sanatlarda başlıyorsun. Evet, hatırlıyorum. Ben de şu an annesi beraber 4 gün sabahtan akşama.
Yes, so she's done. Good. Okay, but it's about. Yeah, he did the same. I think it's like one of these. Yeah.
Again, that's just there. Yeah.
So is.
Yes.
Should I start? Okay,
Yeah.
thank you. Thank you so much for including the paper into the program. I'm going to present a paper that involves a large scale RCT, several RCTs actually. I'm going to present on single one that involves multiple rounds of data collection. The last round of data collection was done in May. I'm just going to show you the main results after 3 years of ordeal in this field. It's joined with my junior colleague, Merve. She is at the University of Göttingen doing postdoc at the moment. So this paper and this intervention is about higher order thinking skills, the development of higher order thinking skills in children. So just to give you an idea what they are, these skills are, one can say, uniquely human skills. Our advantage in this world as species, humans, we have a way of sophisticated reasoning that we think this is unique to us, although it's becoming more and more clear that some great apes have some of these skills, but mainly unique to us, actually, these advanced cognitive abilities. There's no way of categorizing them, but I'm just going to, for the purpose of this study, I'm going to categorize them into two. And one category is the nonverbal perceptual reasoning of human beings, and the other one is going to be the verbal that requires reading skills, which is unique to humans. So perceptual reasoning includes fluid intelligence, like things that we know about how to how to measure now very well, the learning speed, the abstract reasoning, and the visual analogical reasoning, seeing a relationship in a context and applying it to another context to solve a problem that is very uniquely human. Although, again, recently we see some of that in the great apes as well. And pattern recognition and mental rotation. These are all perceptual reasoning skills, the higher order reasoning skills. And the verbal ones require, again, I said reading comprehension and verbal reasoning. And the most important one that I'm going to pause a little bit later on about the critical thinking skills. And the critical thinking skills, when we think about that, I'm going to come back to it again, but it's basically evidence, seeing evidence, evaluating that evidence, and making logical inference and detecting logical flaws in arguments, reaching an informed conclusion and justification of that conclusion. It's something that we really, really want from everybody. And another one that straddles between verbal and nonverbal is the cognitive empathy, basically the theory of mind skills that apparently not uniquely human. Again, apes have some of it. So why do we care about these skills? Well, we care about learning. We care about how much our children learn. And we also care about in recent decades that our children are not learning as much as we like them to learn. So there's a global learning crisis, we call it, and we don't see our children are reading and understanding what they're reading as much as we like them to do. When we look at learning, economists, of course, focus a lot on test scores and GPAs and all that, but I'm going to call that in general learning, basically knowledge accumulation. We learn by our executive functioning. So we have to have attention, we have to have a working memory to learn something that is presented to us. As we accumulate knowledge, we develop some reasoning skills. So this learning is important, and that develops higher order reasoning skills. Without learning, you can't actually develop this. So this is important. I'm highlighting because people say, now we have AI, we don't have to know the facts. So facts are not that important. Reasoning skills are important. It turns out you cannot reason if you don't have much knowledge. So higher order thinking skills enables us to use the knowledge to connect ideas, reason, solve problems, and create new ideas, which we call innovation. That is uniquely human. So they also include on the social side, especially the verbal ones, the critical thinking skills and the theory of mind is essential for our human activities, human relationships, and they are also very important for us as species to thrive. Individually, because they're fundamental driver for learning and further learning and academic achievement, our career development and social success, but it is important for success of our species. So we just need these skills and hope that we are not losing these skills in the age of AI. So that's another topic. So higher order thinking skills develop just naturally. So the kids born and they learn and they're exposed to a lot of stimuli around, and then they accumulate knowledge and they develop these skills. They emerge nicely, gradually as their brain mature. So this development is shaped by the executive function growth, memory and attention, learning, and the learning actually develops these skills. And then continues to develop into adolescence and well into adulthood. We are still developing those, actually. So schooling is important. Schooling is very important in the sense that we know in the last few centuries that the way we think, the way we abstract, and the way we solve abstract problems developed, and the schooling has a lot to do with it. So schooling provides structured opportunities for learning and reasoning. Schools provide exposure to rich language, which turns out to be very important. And that gives us, the schools gives us guided problem solving opportunities. And more importantly, for the purpose of this paper, the schools actually put high cognitive demands on children. They force them, they burn their brain so that their brain develops. So, not surprisingly, the children from poor background have less of these opportunities. We know that now from large literature that SES differences shape early environments that supports or limit learning in general, but also turns out limit developing higher order thinking skills in children. So the lower SES setting often provide fewer cognitively stimulating interactions with your parents, with your surroundings. It provides you, importantly, less complex language exposure. I mean, we know that a poor child has millions of words less when they reach their age four, millions of words less than they heard those words less than the rich kids. So that actually has a lot to do with IQ development up until the age 3 and age 4. So they do have fewer opportunities to practice complex reasoning and self-regulation. And of course, poverty creates stress and instability in the house that also affects the development of these skills and learning in general. So these disparities translate into slower trajectories of higher order thinking skills. They do develop, but in a kind of a slower way. So what do we do here? That I remember I actually highlighted the high cognitive demand feature of schools. So we asked the question, if we take these poor kids that actually lack these stimuli, can we place extraordinarily high cognitive demand on them at the primary school environment and accelerate the development of these skills? By doing so, accelerate learning, and by doing so, actually you see the feedback effect back to the higher order thinking skills, so these kids do better, right? This is not going to be a gap closing paper because I'm not going to have any rich kids in the data, but I'm just going to show so that actually by doing that, can I actually improve their outcomes significantly? So with that, we got a lot of help from really good neuroscientists to design for us a 2-year, very intensive brain burning exercise curriculum to implement in Turkish primary schools. So these were very cognitively demanding exercises for children and also turns out for teachers. So the idea the neuroscientists have is just like exercising your muscles idea, right? If you are faced to tasks that are too easy, you don't develop. If you're challenged too much, you don't develop, you give up. But you have to have the optimal challenge for your brain to develop in any way, whatever the task is. So that in mind, these people prepare this great exercise curriculum for us to be implemented in grade 2 and grade 3. And they were very intensive, so intensive that actually we did crowd out actual learning. So we did crowd out the curriculum, the national curriculum, and that was a big risk to take. So the idea was by cognitively pushing the kids in certain ways, we were actually improve their capacity to learn, so they were going to learn the national curriculum faster. So that was the idea. And then in the grade 2, very low crowd out happened because the grade 2 curriculum was very light anyways, but in grade 3, we did crowd out the kids' actual learning material, the national curricula. And in the grade 4, we didn't do anything. So we just measure the persistence. So the idea here again is splitting the higher order thinking skills into two, nonverbal, perceptual, and verbal. And what we did was, with the help of the neuroscientists, we targeted some of the nonverbal, perceptual, higher order thinking skills. We pushed them for 2 years, very intensively, like 2 hours a day at least, right? And hope that other things that we didn't target got boosted, including the verbal higher order thinking skills, including critical thinking, is boosted. And that would improve the learning, and the learning improves back these skills. Okay, so so we didn't target everything. We targeted a subset of them. So here is the program content. In the year 1, the kids, of course, I'm not going to show you this. We have some program content here, and all of them are nonverbal. We didn't do anything about the reading. We didn't do anything about the numeracy or anything like that. Just like these challenging cognitive exercises started very easy, and then slowly harder and harder and harder, even for teachers, even for me, and sometimes, right? Categorical reasoning was important. Like basically at the end, they were like really competent kids in topology, right? And pattern recognition was another one. And in the year 2, they focus on analogical reasoning and logical reasoning and pattern matching, like seeing the inconsistencies in patterns. So if you want, I can talk about how challenging they could be, but what happened, but we always monitor the teachers. Teachers would say, okay, 5 of my kids are really good at doing stuff. Can you send us more challenging materials? We would send them more challenging materials for those 5 kids. And some of the kids were not really catching up. They would move back and do more easier ones and then come back again. So we actually cater to the heterogeneity in the classroom as well, so that the kids are always challenged and having fun. So that required actually really challenging the teachers at the beginning. We had 2 rounds of extensive training at the beginning of the grade 2, sorry, and then grade 3, we convened them again. And they had to study these materials. They had to master these materials themselves, which was the challenge from the beginning, because again, easy ones are easy ones, and then the hard ones really challenge the teachers as well. So after doing that, they were supposed to give this at least 2 hours a day in the classroom. And typical Turkish primary school is 6 lecture hours in a day. So it's a big intensive intervention. Okay, so they did it themselves. And we did monitor. We were on top of them, right? Because there were times the teachers saying, are we really sure about this? Because, you know, I'm not able to teach the other things because of this. And the kids love this so much that I'm happy to do it, but I'm worried that, you know, the reading is not going to catch up, the numeracy is not going to catch up. But we were on top of them all through these 2 years. So the evaluation design, we did, yeah.
That's the daily timetable, or it was just you fit this in and you take out everything?
Yeah, but we told them whenever you want to do, but we actually tell them not that try to do it in the morning hours mainly. The reason being is late hours are physical education. One thing I did not want to crowd out is the physical education, because that is also important for brain development for this age. So, because that's the first instinct they have, right? Like, okay, I don't want to crowd out math. I want to crowd out the physical education. For this age, I disagree with that. So, that was the only time. But did they do it or did they not do it? I don't know, but this was the suggestion. So we picked 2 southeastern cities in Turkey for this. One of them is very big, and it's also happened to be my hometown, right at the Syrian border. And what is about them is like they're big. They're predominantly Turkish speaking. The other one we picked specifically because those kids are bilingual. Those kids are Kurdish kids, and then they actually come to school with not knowing Turkish much. But the language, but the medium of instruction is always Turkish. So they actually bulldoze over that. So it's just we don't do anything Kurdish in the classroom. So they have to learn Turkish along with the curriculum. So the way the reason I picked that is because I wanted to know the interaction with the verbal development, the verbal reasoning development, the critical thinking development, how it interacts with like you learning stuff in another language, not in your own language. So the sample size overall is we picked 130 32 public primary schools for this in very disadvantaged neighborhoods in these provinces. And that amounts to more than 14,000 students. So the treatment assignment is 67 schools assigned to the program, and 43 in one province with the Turkish speaking, and 24 in the Kurdish speaking. So this is cluster randomization. Unit of randomization is school. So there is no spillover sort of problems we have. So the timeline of the program is indeed year one, as I said, what the kids did, the pattern recognition and analytical categorization. Baseline, they were very little. At the beginning of the grade 2 even, they didn't know much reading. They couldn't read that much. So at the grade 2, beginning of the grade 2, September 2023, we measured, we used the tests that are known tests, fluid intelligence test. I'm going to show you a little bit what it is. Everybody knows it's actually Raven's test. Analytical categorization test, I'm going to show you, and cognitive empathy test, theory of mind, and literacy and numeracy. Up until then, how much numeracy and literacy they had, we measured that. So that's all we could measure at that age. They could not answer survey questions at that age. Then at the end of grade 2, after they went through the pattern recognition and categorization, we still measured those, all the 4 things that I say, and added analytical reasoning, working memory, and attentional control tests on those kids. So, and those were all known tests I'm going to show you again. At the end of grade 3, all of them again, and we added a critical thinking task. No, there is no known task that measure critical thinking in this age of children. So we develop a task, and I'm going to explain to you what kind of a task is that. At the end of the 4th grade, which is the end of primary schooling in Turkey, that was last May, we collected all of them again and added one more component to the critical thinking task, which is inconsistency detection. So the evaluation of the program is going to be all these outcomes, but I'm going to categorize them as, again, nonverbal higher order thinking skills. These are abstract reasoning, analogical reasoning, and categorical reasoning. Those are, some of them are targeted, some of them not, by the intervention. Executive functions, working memory, and attentional control, we had no idea how we affected those things. Those are really, really hard things to push anyways. Verbal higher order thinking skills, theory of mind, that is empathy, and the critical thinking and its components. And of course, we are going to look at the academic performance. Yeah.
Effect of a curriculum, effect of teacher training, or a combination of better teachers with better curriculum?
Combination, because I'm going to show you the teachers got smarter as well with this one.
Yeah, I'm wondering about at the beginning, you mentioned that, kids, if the thing is too easy, they get bored and they don't learn anything. If it's too hard, then they tune out. And for a lot of kids, that's how school is.
Yeah.
So very early on, they either get bored and decide not to pay attention, or they tune out. So if this task is engaging, I'm just wondering whether that's really, like, is the task itself important, or is it just that you've now engaged kids in something they think is interesting and is calibrated to their level, and so then you get more engaged.
Yeah, probably like when they do the tests, that non-targeted tests, they have higher motivation, they have higher engagement to do those tests. It is possible that, but it is, so we target very small number of skills, and every other skill that is boosted, we measure through tests and learning. The literacy and numeracy tests, they hate them. They always hate them. So, but they do better in those tests. But you're right, it could be the on-the-test motivation. We may have created kids that are, which is highly likely because I'm going to show you, we improve their working memory and attentional duration. Yeah, yeah.
Reading curriculum, for example, where the reading is geared to the child's ability, and then they do harder things, you know, as they master simpler things. So
Possible.
you could target different skills and see whether you get the same kind of effect.
Yeah, possible. Yeah, yeah.
Do you have any behavioral outcomes like disciplinary problems, stuff like that with the kids? Like maybe they behave like them?
Not, we collected those, not yet here. Yeah, we collected those from the teacher. They are too young to have official disciplinary recording. But we asked the teacher, we don't see anything there yet, but some of the really hyper kids calm down. That we can actually see it. Yeah. School attendance, their primary school, the school attendance, there's no effect, right? So we know that, like they do come to school, yeah.
They asked them, like, absence was an issue at this point.
Not much, not much. At the primary school level, they do come to school, yeah.
Have you thought about making this available to your team?
To you, Benny, sure. I'm gonna do an attention test on you. Okay, so what did we measure? I'm just gonna quickly go through our measures. They're really fun measures, and then these ones are not ours, of course. They're like known tasks, and I'm gonna spend some time on the critical thinking task that we developed. So everyone knows Raven. Raven is a nonverbal test of testing abstract reasoning and fluid intelligence, and then these and also speed of learning. If you actually correctly implement this, that also measures the speed of learning in children. So a very well-known test. Another test is analytical categorization. I'm going to give you the short, simple versions of the test because the test had, of course, difficult items as well. So that I didn't know about this until I got into this. So the cognitive psychologists look at analytical sorting and holistic sorting type thing, and I didn't know what it means. So you look at three items there: dog, carrot, and rabbit, and I ask you, what group group the ones that are that makes sense to you, the pair. Which pair makes sense to you? A lot of the kids say carrot and rabbit. And of course, dog and rabbit also make sense. It's an animal category, right? And then apparently the analytical sorting is dog and rabbit, like it's a scientific sorting, right? And the carrot and rabbit is a functional sorting, right? And they claim, the anthropologists, like the Eastern people sort more holistically, functionally, and the Western people sort more scientifically and all that. I don't know that, I can't test that, but that's how I got this idea, this whole sorting idea. So the analytical sorting will be the categorization of like animals. That would be the analytical sorting measure for me. Okay, so analogical reasoning, again, a very simple example that just blew kids away and the teachers as well. So this is an easy one. Of course, it gets very, very difficult. These are the tests. Right? We didn't actually teach these kids, obviously, these things, how to do these things. These are just the measurements at the end line. And so honey to bee, what would be for the cow kind of thing. So it gets really progressively hard as they grow in age in the test, so the number of correct answers for B, and then the very tricky stuff, right? The very tricky stuff underneath, you see the options. This is by far the hardest task I have ever done in my life. And believe me, it is so hard. The working memory is so hard. So the kid sees these shapes for 10 seconds, several of those, and the question comes, how many of them were green? Randomly, right? How many of them were like stars? So you don't know which question is gonna come, so it's very, very hard. It's like the score is very low in this, and apparently, I mean, when I look at the teacher data, young teachers are worse than the older teachers for this one. And I have some theories behind that, but just like, this is a very hard task. But it is a very important thing. The working memory is so important for our children to learn. So, for example, at this age, the teacher comes to the class and says, open your notebook, write the date on it, and write your name on the notebook, right? Half the class just opens the notebook and forgets the rest. Like taking command from the teacher is very, very important, and it's getting less and less over time. We see, like, for the 15 years I've been doing this, it's getting less and less in terms of getting that commands. And the teacher sees this as they can't take commands. What's wrong with the kids? It's actually the working memory issue more than anything, and it's coupled with the attentional duration issue. Without that, you cannot learn, apparently. You cannot learn anything if you don't float things in the working memory. You can't learn math, you can't learn reading, because reading is the same. You read a sentence and follow the argument in the second sentence and the third sentence. And if you cannot float those arguments on head, you cannot get what we call the reading comprehension. Yeah. So this is the test we did from the beginning on until the end. The same test. Attentional control test. This is not our test. This is a very well-known flanker test. So for seconds, the kid sees these arrows. They have to focus on only the mid arrow, and whatever the mid arrow is, they press underneath. So very easy to do, the first one. The non-congruent ones are the difficult ones. They keep changing. So that actually, the number, but attentional control measure here is the difference in correct responses between congruent and incongruent trials. So they do this so, like, I don't know, I think we have trial period, the second trial period, 40 toward 100 questions like this, very, very fast. So cognitive empathy test, probably lots of people know, reading the mind in the eyes test. You look at an eye and you just guess the emotion in the eye. Very, very difficult test, apparently for men especially. Yeah, we have the gender difference no matter which population we try this. Men can't see the emotions. So the critical thinking, there was no way to measure the critical thinking ability in these kids, how it develops. So we actually designed a task for this. For this, we just step back and think about what is this critical thinking that everybody is talking about. The formal education is not emphasizing enough, and our kids are kind of losing this, and it's very important for our progress. So turns out the definition is very clear. It's the ability to analyze information and evaluate evidence to reach reasoned judgments, and instead of accepting claims at face value. Okay? So as scientists, this is like, well, this is what we do, we hope, right? So, and that involves distinguishing relevant from irrelevant information, evaluating the credibility and consistency of evidence, drawing logical inferences and available information, and explaining and justifying one's reasons. So we think about, these are really, really abstract concepts. How can we actually measure in children how these things are developing? Okay. But one thing we knew, and we talked to the cognitive psychologists about this, it requires reading comprehension. it requires reading and understanding what you're reading. So it requires all sorts of other cognitive processes that I was telling you about. Okay, so for this, we develop a novel task with two distinct components. In the first component, the children have an incentivized mystery solving task that they have to read a mystery. There's a mystery, something is missing in the school, right? And they have to find that, like a detective. We call it a detective game, right? They have to find, but to find, they have to follow the clues. And the clues were sequential narratives. And from every clue, they had to eliminate the inconsistent hypothesis. Based on the clue, very subtle clue, they had to eliminate where this whole missing thing, this missing thing cannot be, where it cannot be. They had to go through this. And every time they do that, they had to justify why they eliminated, where was the clue, okay? So this gives us the ability for evidence evaluation, logical inference, and argument justification part of the critical thinking. In the second part, they had to read a narrative of 30 plus sentences, all numbered, and identify a very subtle logical inconsistency between two sentences. Maybe the first sentence or the second sentence and the 34th sentence, there's some illogical connection that they had to spot. So that gives us the ability to detect logical inconsistencies, which is another component. This task is not going to get everything about the critical thinking, but whatever we can get for this age children is we are trying to get. After doing this task, because it's a new task and it's not tried, of course, we look at its validity. We look at its predictive validity, what it is correlated with. We created index with all these abilities, and then we correlate them with all the other stuff that I showed you: fluid intelligence, analytical categorization, cognitive empathy, executive functions, and academic performance of the kids. So for everything, this task just highly correlated with all these cognitive skills. Yeah.
These seem like remarkably high, I was curious what the retest reliability of some of these measures are. Sometimes this almost.
Very reliable, these tests.
I see.
Extremely reliable, because we keep doing that every year. So we can actually see the consistency. Of course, the kids are developing. These are developing kids, right? There's a trend, but they're extremely reliable, right?
The real upper bound here,
The one will be strong, but yeah, they're very stable. We have one at a time, but also I like to control for IQ. Yeah. So we have a very similar result controlling for IQ. The critical thinking is correlated with analytical working memory, attention control, all of that. Yeah, controlling for IQ. Yeah, we have that as well. So I'm gonna give you some main results, like how this intervention actually boosted some of these cognitive skills and the non-targeted cognitive skills, including academic achievement. So overall, let me give you the overall index. There's a huge impact on the non-verbal higher order thinking skills. There is impact on the verbal, not as big. Executive functions, memory and attention, we have a very significant impact. And academic performance, we have very significant impact. We have impact in every direction. Just like the neuroscientists would say, you boost something in the cognition dimension, and the other cognitive skills also are boosted. Yeah.
So is this after the first year, or?
This is average.
And then how did you explain to the control group why they would take this test?
Oh, How did I explain the control group? Why? The kids or the teachers?
The kids, yeah.
That goes back to the recruitment. Recruitment of the teachers where I recruited the teachers in the following way. Okay, we are going to do something that we would like to boost learning because we are all suffering of learning, right? So would you like to come to the study? If you actually say yes to this study, you have a 50% chance of being in the study. If you say yes. So of course, some teachers say, could I really be in the study, please, please, please? But, we could not commit. So they wanted to be in the study. So next year, they're all getting this curriculum now. So they were promised to get all of it. Yeah. So, yeah.
In classroom observation, I'm wondering if the teaching methods changed for the non-new curriculum.
I did not barge into classroom and see the teachers, but the thing is that I did collect the styles and the classroom management strategies and everything. I'm going to show you, if I have time, I'm going to show you some amazing results from teachers as well. So let me open up these ones for you. So just like your question, that was all average. Now, you see the average again in the red. The first average you see, I repeat there. And what happens in the grade 2? What happens in the grade 3, and the final grade that we completed in May. So the kids were under intervention in grade 2 and intervention in grade 3. There was nothing on grade 4. We could not do anything in grade 4. Grade 4 curriculum is much heavier. So we actually, pulled back. And so that gives us the persistence of the results. So what we see here is every metric in every year is kind of affected. So we see academic performance not significantly affected in the grade 3, but I was so relieved to see that we did not negatively impacted the academic performance there. So I was happy to see that. Because we were afraid of that. So let me open the non-language based outcomes, like going which skills actually changed in the non-language based ones. Again, all of them, okay? So abstract reasoning, categorization, analogical reasoning, all of them improved. Just look at the grade 2. We did not do anything about analogy. Even grade 2, it improved, right? Grade 3 and grade 4 is persistent. These are really large effects. These are really, really large effects. Executive functions, working memory, and attentional control improved. We see some fading away in grade 4, but overall, they look pretty amazing. The non-language ones. The language-based outcomes, which I cared a lot more about, were not targeted at all. I put academic performance under language for a reason, even the numeracy. The way we measure the numeracy is based on the national curricula, the problem-solving skills. So they are math questions, but verbally presented math questions. That's why they're under language-based. So verbal is cognitive empathy and critical thinking significantly improves every grade. We did not have the task in grade 2 because they could not read yet. So grade 3 and grade 4 critical thinking improved. Academic performance improved. These are non-trivial sizes for education, by the way. They're all standardized, standard deviation. So they are not huge, but they are non-trivial magnitudes for verbal. We look at gender, you can imagine what happened. In grade 3, we saw the girls really picked up. The boys were behind a little bit, but in grade 4, they actually recovered. So I'm not going to show you the gender results. Boys, girls, there's not much difference, but there's significant difference in the verbal development of kids who learn stuff in their own language versus kids who learn stuff in another language, dominant language. So I call it L1 instruction and L2 instruction. So for the language-based outcomes, the perceptual outcomes, there's almost no difference. Kurdish kids, Turkish kids did well in everything. Okay, so there's no heterogeneity. There's not much heterogeneity there. It's a little bit attentional control, but that's not much. But for the verbal, all the effects are coming from kids who learn everything in their own language. So the critical thinking, cognitive empathy, all of it, all the verbal-based stuff is coming from verbal improvement, verbal reasoning, academic stuff is mainly coming from the kids who learn their everything in their own language. So this was my prior wasn't this. My prior was the bilingual kids have the advantage, some brain advantage of seeing different things differently. I mean, it just didn't pan out. But we will follow these kids. Maybe they will actually develop it later. But at the moment, they seem to have this disadvantage. Yeah.
Do you have it's like scores? You know if it's like complementary based on
We look at the baseline. We collected baseline. There is not much on the ability heterogeneity. We look at that baseline IQ. So if the kids, there is some evidence that the low got more out of this, but it's not enough to say that this actually low ability improved better. We don't have much heterogeneity there. We did look at it. Okay, now, why did this really work? I mean, the neuroscientists that I work with, they're not really surprised. They're just like, we push the kids, we push the limits, they should expand and they should do better, right? So it was effective in improving core cognition, attentional duration, working memory, all the stuff that we didn't even target. And it improves the verbal stuff, verbal ability, verbal higher order thinking skills in the L1 context. So the idea is this is a good period to target these skills, and we place sustained cognitive demands on these kids who don't get these demands from their houses, from their homes. And if we could do that, it looks like actually we can help these kids quite a bit. And this is consistent with the evidence of cognitive neuroscience that cognitively demanding activities can expand cognitive capacities. And that's why the SES gradient that we see, a lot of people say the SES gradient is basically the stimulus quality in the environment. So despite substantial crowding out, which was relieving for me, despite substantial crowding out, the kids did better academically overall relative to the control. So teachers, we really push them, and I was worried about a lot of stuff, right? And I tested them as well. I tested their cognitive skills. I tested their IQ. I tested their cognitive empathy. I tested their analogical reasoning abilities, all the tests, and they do improve those as well. So this, I wasn't sure, is it the test-taking motivation or something else? But when we look at this, that comes, I'm not going to show, but all these cognitive gains in teachers come from young teachers. Teachers of my age did not improve these things, right? So all coming from the very young teachers. Teaching styles, we don't have a lot of change in the styles. Beliefs and attitudes, now the growth mindset, the teacher saying, I believe the brain can actually develop, improved quite a bit. And one thing I was worried about the mental health and burnout, because I really burned them out. I know I did. It actually is negative, right? So they feel like when I talk to them about this, they say, well, we teach faster now. So the kids actually absorb faster, they pay attention more, they have less kind of, they calm down a little bit. So they were quite happy about this. I'm going to conclude now. What we're going to do with this is we're going to actually push it to the preschool so that we don't have to crowd out anything. And to improve the quality of preschool, we are going to push all these cognitive exercises to the preschool in Turkey as a scale up to actually make these kids' brain ready for learning. Yeah.
So since there are well-studied preschool curricula, say Montessori schools, right? it would just be interesting to compare what you're trying to do here with some of the things that have already been done, like what are the common elements?
Right, right. Yeah, we will look at that, and hopefully we can actually do some experiment on that as well, because there's a Montessori preschools in Turkey too, quite a bit. Yeah, yeah.
Yes, it's just one more extent, and see that just the main more progress and those for the kids that over those who were taught by the teachers. It's all right.
Sorry.
There is an information in the performance of the teachers.
That I can't. I don't think we can look at that. I don't think we can look at that. So, I mean, we can try to look at it in a kind of suggestive way, but the causally, I don't think we can do that. Yeah. Yeah, okay. I just said, I'm happy to talk about more.
Okay. We have to end here.
Yeah, that's why.
Carries for break. No, go far.
Okay, so we start directly from the contribution for people at home. The first one is on the determinants of the motherhood penalty with a particular focus on flexibility. And here our advantages are threefold. So first, we have detailed matched employer-employee panel records and actual work from home contracts that would help us address sorting and selection of women in more or less remotable jobs. Second, we would be the first study of the penalty using actual work from home contracts rather than only proxies for flexibility. And third, the scale and granularity of the data would allow us to use heterogeneity as a diagnostic tool to study mechanisms. The second contribution is more generally on the literature of work from home effects on worker outcomes, showing that these effects are state dependent and they tend to concentrate around parenthood and crucially depend on household characteristics. So in terms of empirical strategy, we have detailed matched employer-employee data on Italy, covering around 800,000 mothers giving birth for the first time between 2016 and 2023. And we have also information linked to fathers. Our empirical design is a dynamic difference in differences on repeated cross-sections of mothers around the 2019 work from home diffusion shock, in which we compare mothers that are in sector locations with different pre-COVID exposure to remotable jobs. And the crucial variable, so our instrument for the actual use of work from home contracts, is this variable which we call remotable, which is going to be the product of two quantities. One is the sector share of remotable jobs. So we basically take the composition of occupation in a sector and see what's the share of these occupations that are remotable at the sector level, and the local broadband speed measured in 2019 at the commuting zone level, which basically measure the internet speed, because without a good internet connection, work from home is actually very difficult to perform. And then we estimate these dynamic specifications in which the crucial coefficient is going to be the beta k, which is going to measure the change in the outcomes y in more remotable versus less remotable occupation in a reduced form setting in each childbirth year relative to the excluded year, which is going to be 2019. And the outcomes which we are going to consider are labor market outcomes such as earnings and weeks. We then use this remotable instrument to instrument actual work from home take-up with the post-2019 exposure. So the identification assumption is that we have parallel trends across more or less exposed sector locations. We are going to show that there are no differential trends for mothers in different cells. We have in the paper evidence there are no effects of this remotability index on firm performance or on sorting across sector locations. And we are also going to use pre-birth earnings in order to absorb time invariant selection into exposure. And in the paper, we also have exercise in which we use placebo births away from childbirth to convince the readers that actually the effects that we show are concentrated around the childbirth window. So the first result that we show is that remotability raises mothers' earnings around childbirth. So here we basically report the beta k coefficients for different childbirth years. And we see that before the COVID-19 pandemic, the trends for mothers in more remotable and less remotable sector locations are parallel. And after the pandemic, we find a persistent increase in earnings of around €1,000. This increase in earnings is driven by higher labor supply, so higher work input. And this is true also if we subtract from earnings 1 year after childbirth, the earnings 1 year before childbirth, in order to account for the fact that the composition of mothers giving birth may change in different years. The effects on earnings are persistent, so they are present also if you look at earnings 2 years after childbirth and 3 years after childbirth. And the effects that we find on weeks worked are actually a compensation for a reduction in the number of weeks that mothers spent on parental leave. So they spend more weeks working and less weeks on parental leave. If we use this remotability variable to instrument for actual work from home take-up, the earnings effect that we find implies that the reduction, that the earnings penalty around childbirth is reduced by about 77%. But there are big heterogeneity effects, and we find that there are larger effects for more constrained mothers, that is, those that are at the bottom of the earnings distribution, younger mothers, and those without a college degree. For mothers in more constrained households, especially those where the father is the dominant earner in the household, and also in more inflexible jobs, with larger effects for mothers that are commuters, for mothers in greedy occupations, as per the definition of Claudia Goldin, and for mothers that work in firms that are less family-friendly, measured as those that historically have higher child penalties. If we look at fathers, we find that fathers do not benefit from higher remotability. Here we basically replicate exactly the same specification, but using the change in fathers' earnings around childbirth, and we find a zero effect. But fathers are important in helping mothers. So the remotability of fathers helps mothers' careers in a way similar to how the remotability of mothers helps mothers' careers. So here basically we augment our specification on the right panel, having on the right-hand side both the remotability of the mother and that of the father. We also find positive effects on fertility. So here we compare a placebo pre-COVID panel of working women measured in the baseline year 2015 with a treated post-COVID panel of working women measured in the baseline year in 2019. And we look at fertility outcomes 4 years after this baseline year. And we find higher fertility at higher parity, so for children after the first one, and also for the first child, consistent with the story in which work from home reduces the cost of the marginal child. So to conclude, we find in this paper that rigid workplace organization is a very important driver of the motherhood penalty. A work from home contract can offset up to 77% of the earnings change around childbirth, or reduce the child penalty by around 30 percentage points. These adjustments happen mainly through labor supply within ongoing jobs. I didn't show you the results, but we don't find results on the extensive margins or employment or on hourly wages. These gains are largest where the rigid arrangements are more costly, so for younger mothers, for lower earning mothers, for those that have to commute and in greedy jobs. And we find, importantly, some household level constraints in that father's flexibility helps mother's career and fertility. Now, I want to leave you in this last minute with one final piece of evidence. So we find that work from home contracts are important for reducing the motherhood penalty, but how much of the life cycle gender gap can be related to flexibility? And here I leave you with this graph. So here we are basically plotting the gender earnings gap, the ratio between female and male earnings over the life cycle. As you can see, this gap increases by approximately 20 percentage points. If we remove, so if we compute a counterfactual in which we remove the motherhood penalty, actually the gender gap would not increase over the life cycle, pointing to how important children are in determining mothers' careers after childbirth. With the current diffusion of work from home, the gender earnings gap would increase by 11% less over the life cycle. And in a counterfactual scenario in which all jobs were performed remotably, all those that could be actually be remotable, this reduction would be higher by 29%. So work from home cannot close the gender gap, but it can meaningfully slow its growth. Thank you very much. I'll have to leave right after the presentation, so if you have comments, please email me. Thank you.
Thanks, everyone. This is joint work with my colleague at UCSD, Julie Cullen. And, we all know the Supreme Court's ruling in Dobbs v. Jackson in June 2022 that basically returned abortion regulation to states. And that prompted a rapidly evolving set of state-level regulations and bans and led to serious concerns about women's access to and use of reproductive health services around the country. Now, a lot of the economic questions in the debate, you can think about them as concerning around efficiency and equity, and particular thinking about effective access, unequal reproductive health burdens, and possible behavioral inefficiencies. So what we want to do in this paper is basically to see where we stand in terms of what is the current state now. So basically, we're just looking at we want to provide a few facts in the post-op time with some newly available data. And here we have access to a nationwide electronic health record. So basically think about all the clinical information that your doctor or provider has on you in the computers. And that covers about 50% of the entire US population. So we're focusing on women ages 15 to 44. We have about 35 million females. And this is 2 years. So all the rates that I'm going to show you are going to be for 2024 and 2025 combined. And the data, what it allows us to do is to link clinical, both pre and post-pregnancy reproductive health outcomes and choices to geography, demographics, vulnerability, and payer. And you'll see that that includes self-pay, but it is going to be very important here in the analysis. And what we want to provide here is basically an account of different margins that relate to access, inequities in adverse outcomes, and potential concerns that some people in the literature have had about some potential moral hazards, behavioral responses. So let me start by talking about access, and here I'm going to focus on variation in abortion rates across 3 dimensions. I'm going to think about the level of locality, think about technology, focusing on medication abortion, and finally thinking about the financing itself. So let's start with the geographic variation in abortion rates that here we have the US map. The borders are going to represent the policy environment. So thick borders are going to be where states with total ban. Intermediate states are going to have this dashed line, and states that have no limits or up to viability are going to have no border. So what you see here is very clearly that state policy is a very powerful measure of access. If you think, if you look at no limit versus total ban, it's 6 times as large. But it turns out to be a very incomplete picture, because where we're thinking about the cross-county variation and we control for state fixed effects, we remain with 69% of the entire variation, okay? One thing that you can think about in terms of local access that people have looked at before is to think about distance to the nearest provider. So here, this plot basically has on the x-axis, this is the log facility distance. On the y-axis, this is the log abortion rate. Both of them are after we control for state fixed effects. And you see a very strong association with distance to nearest abortion provider. The elasticity is about minus 0.2, but that alone can explain only 8% of that remaining variation. Now, when we wanted to think about what is the marginal mode to think about, what is more relevant for policy, we wanted to see we know that medication abortion is increasing generally over time as a share of all abortions. And what we have here, we plot on the x-axis, we have the abortion incidence rate. And on the y-axis, we have the share out of those abortions that is medication abortion. Okay, on the left-hand side, you see the correlation across states. On the right-hand side, this is the within state across county variation. So basically, you see that it's very strongly holds in both of them, the correlation, meaning that the medication abortion is the marginal abortion mode, and underscoring the potential role for telehealth in moderating access. Now, finally, when we look at access, we wanted to look at public financing, and here we found that it shapes who pays. On the left, we've identified around 900,000 abortion encounters, and we wanted to see the distribution of payers. And you see that the single largest payer is Medicaid, that pays about 35% of all medication across the US. But that, of course, as you might have in mind, it varies dramatically across states. On the right, we have the borders are going to be the thick lines, the black thick lines are going to be states that cover, that Medicaid covers abortion, and in the other states that it's not covering abortions, and you see that there's very large distribution across them. Now, Delaware provides us with a very nice quasi-experiment here. So, so the left here, this is from Delaware. On the right, that's all other states as a placebo. And what I plot here on the x-axis, this is time in quarters. And what happened in Delaware, that at the beginning of 2025, there was a mandate that Medicaid cover abortion. So what you see very clearly is that there's a jump in the Medicaid share, so from 7% to 38%. But very importantly, you see that there's an offsetting decline that is coming mostly from self-pay, okay? And if you look at the total encounters, this is the top line, you see no increases, and if anything, there's this gradual decline, okay? This is something that we would miss. This is a data point we would miss if we looked at claims data alone, because we will, by construction, miss all this self-pay. So what we have here with this quasi-experiment is that the finances shifted, but the total abortion encounters did not increase. When we move to look at equity, here we were interested in looking at disparities in reproductive health outcomes, and we look at two outcomes. On the left-hand side, we have fetal and neonatal mortality or morbidity. On the right-hand side, we have, based on the CDC survey, this is a proxy for unintended or missed time births. So we're focusing on ages 15 to 24. And I'm going to show you two dimensions of heterogeneity, one by SVI. SVI is the CDC's social vulnerability index. So higher SVI is more vulnerable communities. Low SVI is less vulnerable. The more vulnerable here are in triangles, less vulnerable are in squares. And there's three things that come out here. First, you see that among more vulnerable neighborhoods, there's a higher incidence of these adverse outcomes across the incidence distribution. But you see it very clearly that as abortion incidence increases, the incidence of these adverse outcomes declines. And one thing that I'm not sure if you can see in the numbers, but that decline is steeper for more vulnerable communities. We see a very similar pattern if I split the sample by Black and Hispanic in triangles and non-Hispanic white in squares. Okay, so together, this is consistent with greater access reducing risk while also narrowing existing gaps. And finally, we wanted to look at some of the concerns that the literature have raised with respect to ex-ante moral hazard. And what do I mean by here? Because if you can think about it, when we reduce the cost of abortion, you may engage in less preventive behaviors ex-ante. So here we're looking at two margins. One is to look at contraceptive use on the left, and the other one is proxies for risky sexual behaviors as captured by STI incidents. Here is chlamydia and gonorrhea. And you see there's absolutely no correlation here, okay? Basically, there's no support for recurrent pregnancy prevention or riskier sexual behavior, okay? So let me just conclude. When we look at access, we see that state policy establishes the legal environment, but the provider proximity, medication abortion, and the public financing shape the realized access. Looking at equity, we see that disadvantaged population face greater reproductive health burdens, but those declines as abortion incidence rises. And finally, in terms of efficiency, we see that broader coverage reduces the financial burden without increasing abortion, weakening prevention, or encouraging riskier behaviors. Thank you so much.
Hello, thanks for including this paper on the program. This is joint work with Aria Golestani, Brandon Turchin, Sebastian Ramirez, who's here in the room, Ben Struhl, and Anthony Braga at UPenn Crime Lab. Funding came from Arnold, and as with all my work on summer jobs, it could not be possible without the amazing partnership with the City of Boston. During the COVID-19 pandemic, many American cities faced a sharp increase in violent crime, including Boston, where we saw a 45% jump in violent crime shootings between 2019 and 2020. This uptick in violent crime prompted a renewed interest in finding innovative solutions to address violence, especially among youth, with mayors like Marty Walsh in Boston calling for expanding job opportunities, including summer jobs programs. In response, the Biden administration urged cities and states to use their American Rescue Plan Act funding to start or expand summer job programs in the hopes that nothing stops a bullet like a job. And about 30 of the largest cities already had existing programs, although few operated at scale. Since then, many jurisdictions have expanded their programs, aiming to make their communities safer during the summer as well as in the longer term. Now, these summer job program expansions were based on a growing body of research evidence across multiple cities, consistently showing that summer job programs reduced youth violence, at least in the short term. For example, RCTs in both Boston and Chicago have shown that youth summer jobs programs have reduced violent crime by 35 to 40% for up to 18 months after the program ends. Yet these studies stand in contrast to the adult literature, which suggests that while workforce development policies can reduce property crime by alleviating economic hardship, they typically have little impact on violent crime. So it seems reasonable to ask whether the reduction in youth violence associated with summer jobs programs can be sustained in the longer term, especially compared to less costly alternatives such as cognitive behavioral therapy. Our study builds on this literature in two ways. First, little is known about the impact in the longer term. There have been a couple of studies in New York City showing a 10% reduction in both incarceration as well as felonies. However, both of those studies were limited to adult offenders and were unable to distinguish between other types of violent crimes. More importantly, there's less information on the mechanisms by which summer youth employment programs reduce crime among youth. So some previous literature shows that there's been a decline that's associated with social emotional learning, but that doesn't appear to be the only thing that's happening here. Much less attention has been paid on the salience of peers, in particular, recognizing that 50 to 75% of juvenile offending is committed in the company of others. And in particular, the greatest concentration of serious youth violence occurs among individuals involved in gangs and other high-risk co-offending networks. So our experimental design relied on youth who are enrolled in the summer jobs program in Boston through ABCD, one of the 5 intermediaries that contracts with the city to place young people into jobs across Boston's 23 neighborhoods. Youth worked 20 to 25 hours a week for 6 weeks from July through mid-August and were paid the minimum wage. They also received 20 hours of career readiness training that included social emotional learning, as well as work readiness skills and other types of skill building. We use Boston Police Department juvenile and arrest records, as well as field interrogation and observation data. Both the arrest and FIO data were matched to the City of Boston's Summer Youth Employment Program records using each subject's name, date of birth, and address of residence, as well as their key demographic information. The arrest data have the advantage of being able to allow us to look at formal criminal charges, including not just the seriousness of the crime, but also a literal description of the crime that allows us to create categories by type of crime using the CJARS coding system. The FIO data actually documents informal criminal justice behaviors, including not only when an individual is stopped and frisked, but also when an officer engages in a consensual encounter with an individual, or when they simply observe that individual and need to document that for intelligence purposes. One big caveat with this data, of course, is not just in the bias of who is arrested and gets stopped, but also that this data is often has some spatial correlation between both police and youth offending behavior, where the Boston Police Department is also often using the FIO data to deploy police to certain crime hotspots and also to focus on certain well-known offenders. So we control for lots of spatial differences by including covariates for neighborhood census tract characteristics. We estimate these intent to treat impacts of the summer jobs program to account for both program selection and take-up. We use equation 1 here, and our primary outcome of interest was on violent crime, including both the prevalence, whether or not you've ever been arrested for a violent crime, as well as intensity, so the number of violent crimes that you may have committed. Our secondary outcomes focused on 2 main analyses. The first was studying differential program impacts by subgroups for those groups that typically are involved with police, including males, older youth aged 19 to 24, and high-risk youth who are arrested prior to the program start. Our secondary outcomes also include examining behavioral mechanisms in 3 different ways. One is the timing of impacts to distinguish between incapacitation effects versus actual behavioral shifts. the impact on co-offending among the treated youth and any spillover effects on their prior co-offending peers, and the impact of randomly receiving a second consecutive summer of participation. We find that being offered a job through the Boston Summer Jobs Program led to lower criminal justice involvement over the long term, but only among the subgroups who were more likely to come into contact with police. So here I'm showing you the results for males. Males experienced an 18% decline in the likelihood of ever being arrested post-program and a 23% decrease in the number of total arrests. You can see that most of that impact is driven by a decline in misdemeanors over time, and most of that is driven by a decline in both property and violent crimes. More importantly, notice that over time, this impact is accumulating. And so actually it doesn't even start to decline until the program ends, which suggests this is not an effect that's driven by the incapacitation of young people being too busy in the summer to engage in any criminal activity. If we look at high-risk youth, we actually find that the reduction in violence is concentrated among this group, and that the left two panels here are showing you that, if anything, we see a large decrease in violent crime of up to 79%. If anything, property crime increases for this group. One might also ask what is going on here in terms of their prior co-offending peers. You might think on the one hand that these positive behaviors are spilling over onto their peers. On the other hand, it could be if they completely cut their ties with their prior co-offending peers, that we wouldn't see any kind of impact. Unfortunately, it looks like it's the latter case that is happening here, where we don't find any reduction in violent or property crimes for the peer group. So what did happen? It appears that the program reduced the likelihood that individuals in the treatment group were involved in co-offending events during the follow-up period because they were subject to less negative peer interactions than the control group. So among that high-risk youth group, the likelihood of being arrested with others fell by 52% and was also accompanied by a 30% reduction in the FIO reporting data as well. So it appears that there's something that's disrupting these social interactions. We also explored whether a second consecutive summer of participation can help sustain or enhance these programs' impacts. To do this, we limited the sample to all youth in the treatment group, those who initially won the lottery in 2015, and estimated the marginal effect of winning a second summer of treatment in 2016. And while we don't find any further reductions, for the most part in terms of incidents, whether or not you were ever arrested prior to the program, we do see about a doubling of the effect in terms of the number of incidents that you're involved in. So the effect on ever being arrested is twice as large in terms of the decline, as well as for violent crime arrests. We also find impacts on the number of arrests and the incidents for property and drug crimes, as well as felonies. So it appears that maybe perhaps a continued or sustained ability to be able to hold a summer job from one summer to the next is really what's needed to drive these reductions in crimes that are associated with economic deficiencies. So 5 key takeaways that I'd like to leave you with in terms of summer job programs. There's clear and compelling evidence that these programs reduce violent crimes in the long term. The timing and impact of the reduction in co-offending suggests that the program changes behavior over time, including that of socializing with prior co-offending peers. Youth that win a second summer experience larger and more consistent reductions in crime across many different types, suggesting that summer jobs programs might want to actually target a second summer at high-risk youth that can be identified by law enforcement. These effects are primarily driven by the high-risk youth, who actually look very similar to what you might think of as opportunity youth. So these are older individuals who are aged 19 to 24, who are typically not associated with school or work. And so this might be one way to offer positive experience to this hard-to-reach population during these active offending years. And finally, even if youth age out of criminal justice involvement, summer jobs can accelerate that process by minimizing the amount of violent crime that they're engaged in during this very crucial developmental period of time, and produce better long-term outcomes for both the youth and the communities they live in. Thank you.
It's a pleasure to be able to share some results of my research on whether students adjust educational choices to parental observability. So because choices are always observable to parents and potential effects of this. To motivate this very briefly, these choices are super important for individuals and society. In many countries, we see certain issues in these allocations. So if we want to understand what might be going wrong or how we could help students make better choices, we need to understand what actually drives these choices. So here I took a kind of different approach to this question and wanted to understand whether students adjust their aspirations and choices because their parents can always observe them, and potential concerns that come with this observability. And then second, I wanted to know whether this also affects the socioeconomic gaps we see in both college plans and attendance later on. To make progress on this question, I developed a career planning module that allowed me to survey the students on what they wanted to do after high school, and then rolled this out at 47 high schools in Germany, and invited both students and parents to participate, and ended up with this sample. But the most important subsample here are 574 students, which had at least one parent registered and with a different contact detail from themselves. And for this subsample, I was able to run an observability experiment where I randomized whether I told students before I would ask them what they want to do, whether I would share their stated aspirations with their parents or not. Okay, so here the only difference is this observability to parents. I mentioned parents in both conditions to make sure it's not the mentioning of parents, but this visibility to parents. I did that in a between subject design. So for each student, I will have only the private or the public aspiration. But as long as students take these questions seriously in both conditions to fix ideas, you can think of private aspirations should be driven by kind of students' intrinsic interests and whatever concerns they have already internalized at their age. So they were 16 to 17, and the public aspirations being driven by whatever drives their private aspirations, plus these social concerns that get activated by this parental observability I introduced. Okay, so here you can think of kind of parental recognition, for example, or fearing disagreement and a few other concerns. What did I find? Looking at whether students want to go to college or not, and distinguishing low and high SES here, where high SES are those with at least one college-educated parent, and low SES without any college-educated parent. You see that even in the private condition, there is a difference, a 13 percentage point gap in wanting to go to college. But what happens when I tell students that I will share their aspirations with their parents? For low SES, on average, I don't see any average movement. But for high SES, they become 10 percentage point more likely to say they want to go to college. So you go from a gap of 13 percentage point in the private condition to a gap of 26 percentage points in the public condition. Okay. So here, yes, students do adjust their education aspirations to parental observability, and in this case, it actually doubles the socioeconomic gap in college aspirations we see. This is driven by students with one college-educated parent adjusting a lot, and actually not by those with two college-educated parents, as those at this age already seem to have kind of internalized or realized that college is what they want to do or what they should want to do. I also see that this is not limited to college aspirations. I see students also adjusting what fields they want to go into. Okay, you can take 5 seconds to form priors about what fields students might move away from and might move to, and you're probably right. So here, students move towards law, business econ. So you might see some of these students in your classes, math, natural sciences, and they move away from arts, music, and design. So yes, we see students adjusting aspirations, but how about choices? First challenge here is I need choice data, and in Germany I can't just get administrative data, so I had to follow up with the students. I did that twice, up to 5 years after initial participation, and managed to reach almost 80% of the students in both conditions. Second challenge here is I can't randomize the observability of actual choices. Okay? So I can't make a causal statement that observability of actual choices causes certain behavior. I have to take a more indirect approach. And here I ask whether actual choices are better predicted by public or private aspirations. So think about a cheap talk case. Students change what they say in my experiment, but then in the end, they do whatever they would have privately said. Okay? So here, choices should track private aspirations, or students actually do adjust choices in similar ways as in my experiment. Here, choices should then better track public aspirations. Okay? And note that this is not about my public condition impacting choices. I don't see any difference in the choices they did depending on what condition they were in, but this is about what better predicts their choices. Okay? And choices in the end are always observed by parents for everyone. What do I find? In the private condition, 68% of students follow through with going to college or not, depending on what they said initially. But in the public condition, this is 10 percentage points higher. Okay? You see kind of the same direction for high and low SES, but they start at different levels in the private condition. How about fields? So here I looked at what field students enrolled in, and then looked at how they ranked it initially in the private or the public condition. On average, I don't see anything here, but this masks heterogeneity because for high SES, they actually enroll in fields they ranked as more attractive in the public condition. Okay? And for low SES, it goes in the other direction. So overall, I see results consistent with the interpretation that this observability might also shape actual choices, especially for these high SES students. Okay? I also see certain choice patterns being more in line with what I find in the public condition, such as the socioeconomic gap in actual college attendance being much closer to what I observed in the public condition than what I observed in the private condition. Okay. But again, this is no direct causal evidence on an impact on the choices. So one alternative interpretation that might have come to your mind is, are these public aspirations just better measures? For example, because students perceive higher stakes, so put more effort. I do a bunch of tests to kind of rule that out, but one I want to share with you is, do public aspirations then also better predict how choices turn out in terms of persistence, satisfaction, and performance? So here I will compare these kind of performance measures with how students ranked the field they eventually enrolled in. Okay? So this is in terms of standard deviations, and positive coefficients mean that if students initially ranked something as more attractive, then the outcomes also look better. Okay. For those in the private condition, I see that there is a positive correlation with ranking something as more attractive initially, and then also being less likely to drop out, not expecting to drop out, not intending to drop out, reporting to perform better compared to peers, and being more satisfied with what you do. In the public condition, however, I don't see such a correlation with their reported preferences initially. Okay? So if at all, the outcomes are more strongly correlated with what they reported in the private condition. And the magnitudes are quite meaningful here, but again, choices are endogenous, so it's not saying that certain things causes certain outcomes, but I'm assessing of which of my measures, the private or the public one, is more strongly correlated with the students' outcomes. And here, overall, I find a two-folded pattern of choices being more in line with public aspirations, but then the outcomes being more in line with private aspirations. So one possible interpretation is that choices are actually shaped by parental observability, which is better captured by my public condition, and outcomes in the end are determined strongly by intrinsic interests, which is better captured by my private condition. Okay. Now you might be wondering what mechanisms are driving this. The experiment wasn't designed to identify this experimentally, but what I see, what gets activated through the public condition, seems to be concerns around parental recognition, rather than kind of open conflict with the parents or concerns around financial support. I don't have time for this, but there is evidence that students and parents are not fully aware of this. So students still think these are their choices. So to wrap up, what I find is that, yes, students do adjust their aspirations to parental observability and likely also choices. So some students end up doing something they did not always privately aspire to. In this case, this widens socioeconomic gaps. And one possible mechanism is this desire for parental recognition, but it might not be, students and parents might not be fully aware. So together you had to have a quite subtle and hard to detect form of parental influence, but which still has the power to shape educational choices and therefore also individual outcomes, social mobility, and the allocation of talents. Thank you.
Thank you for staying for the very last talk, the very last day, the very last session. I'm sorry.
Well, thank you for saving us for the second to last talk of the very last day of the very last session. So first, thank you to the organizers for including us in the program. I'm Margaret Lay at Mount Holyoke College, and this is Love in the Time of Zika. So to start, I'll start with a familiar figure. Fertility is declining in countries across the world. Brazil, the red line here, suffered an epidemic of a mosquito-borne virus called Zika that led to some severe fetal health risk in the mid-2010s. And as you can see, fertility in Brazil is declining right along with the rest of the world. At the same time, a global trend that is often linked to the decline in fertility is an increase in female labor force participation. And again, Brazil, the red line, is emblematic of this pattern. But labor and fertility decisions are often intertwined with lots of other lifetime decisions. How do mothers and fathers choose to spend their time at home and in the workplace? What partners do people choose to share their responsibilities with? Do they choose to partner at all? And the question that we ask today is going to lie at the intersection of these decisions. In particular, we ask, how does a one-time shock that raises the cost of children affect adjustments in fertility, women's employment, and family formation? And in turn, do these adjustments make the initial decline in births more persistent? We'll use geographic and time variation in the Zika virus as a natural experiment. And in short, we find that this aggregate shock to fetal health risk is associated with a decline in monthly births, fewer new mothers in the long run, persistent increases in employment and earnings, and increases in divorces and marriages. Our hypothesis here is that the short-run adjustments that people are making in response to the Zika shock, forming attachments to the labor market, or initiating conversations about household responsibilities and fertility preferences, are shifting families off of their original path and onto a new trajectory. So, how do we use Zika in our research design? Zika first showed up in Brazil in May of 2015. At the time, it was considered completely benign. Many adults that got the virus didn't show any signs of symptoms, and for those that did, the symptoms were really quite mild. But later that year, there was a troubling increase in the number of babies born with severe brain abnormalities in areas hard hit by the virus. And so scientists linked the virus to microcephaly and other severe fetal brain diseases in October of 2015. In November of 2015, a national health emergency was declared, followed by an international WHO emergency. Now, we're going to use that declaration of the national health emergency as an aggregate shock to fetal health risk and trace out its impacts on fertility, employment decisions, female employment decisions, and family formation. And to support our assumption that Zika only influenced these decisions via its impact on fetal health risk, we're going to point to the timing of the responses that we find, but also some characteristics of the virus and the public health response itself. So first, fetal mortality rates were not substantially elevated by the virus. And unlike COVID, there were no government-imposed restrictions on worker mobility, and these mild, short-lived symptoms in adults made it unlikely to keep adults from working if they caught the virus. So we're going to separate municipalities into treatment municipalities with high Zika intensity and control municipalities with lower intensity. And one key aspect of our research design is that people, in fact, were aware of the fetal risk that was associated with the Zika virus. And so to ensure that we capture the salience in our treatment, we're going to take advantage of some of the public health response that was launched with the national health emergency. In particular, this public health response was an informational campaign targeted at women of childbearing age, letting them know about the risks associated with Zika. So as part of this campaign, the government of Brazil released this maps that categorized the different municipalities according to case incidents within the municipality. And these maps repeatedly use these same discrete incidence categories and the color coding that you see here to publicize the geographic concentration of the Zika virus. So these maps effectively identify our treatment groups. The municipalities in red are government identified high-risk areas where the government was focused on spreading information about the virus. And that's going to be our treatment groups. And then the other is essentially our control. So we obtain the municipality level case incidence data underlying these maps, and we exploit these discrete incidence categories to create a binary measure of treatment that mimics this distinction. So our ultimate specification is going to be an extended difference in difference, where the treatment groups are the high Zika salience areas, and the treatment itself is the national health emergency. And so here you're seeing the results from that specification when the outcome variable is monthly births within a municipality. The first red line is the declaration of the national health emergency. The first black line marks 9 months after the declaration of the health emergency. And the second black line marks 9 months after the effective end of the epidemic. So if the decline in births were a result of increased miscarriages as a result of the virus, we would see negative coefficients between the red and the black line. But instead, the decline is concentrated between the two black lines, which is consistent with intentional pregnancy avoidance. So the average monthly decline in this period is over 6%. This is large, but it's in line with existing studies on the Zika virus. Now, one might be concerned that using diagnosed cases within a municipality could introduce some endogeneity to hospital infrastructure or other municipality level trends. As robustness checks, we use 2 other measures of Zika intensity to identify our treatment groups. The first, in panel B, we use the geographic suitability for the Aedes aegypti mosquito, which is the mosquito that carries the Zika virus. And in the second, panel C, we use stratum level Google searches for the term Zika. And you can see using both measures, we have very, very similar declines in monthly births. Going forward in this talk, we'll focus on the Zika cases measure. But one thing I want to highlight before moving on is that across all of these measures, in none of them do we see a rebound in birth. These coefficients never turn positive after the epidemic is over. So we'll dig into that trend a bit more with these figures here. So here we're aggregating the monthly declines you saw on the previous slide to create a cumulative measure of foregone births between the epidemic and the end of 2019. And so in panel A, for example, you see that there were significantly fewer babies born in high Zika intensity municipalities between the declaration and the end of 2019. This cumulative decline results in, it translates to 5% fewer children in all, and that's concentrated among women without children. So women with children in panel C are recovering their fertility by the end of 2019. Women without children are more likely to not become mothers at all. And so in the end, these high-risk municipalities have 20% fewer new mothers in this period than they would have without the virus. So these impacts on fertility show that Zika, even though it was concentrated into a very small period, less than a year, had lasting impacts on fertility. This puts it in the same category as some permanent changes that impact fertility, like changes in government support, cultural norms, the introduction of the pill. We next look at the impact of Zika on employment, women's employment. In panel A, you're seeing the outcome variable is a binary indicator of employment. In panel B, it is women's monthly earnings. You see that both employment and earnings start to increase about a year after the declaration of the national health emergency. This is consistent with the 9-month gestational period plus a 4-month period of paid maternity leave and employment protection that Brazilian mothers get in the formal sector. We can use these estimates to create a pseudo-child penalty, and we find that for every 10 fewer new mothers, there are 4.5 more female workers in the workforce. This is big, but Zika is an aggregate shock, and so this likely includes some general equilibrium adjustments, firms being more likely to hire women who they don't expect to become mothers. We also see an increase in divorces and marriages, which is consistent with a reshuffling of partnerships. So one potential explanation for this reshuffling is that the Zika shock kind of jolted inter-household bargaining and family planning. It's possible that this fetal health concern lifted some taboos and opened some conversations about inter-household responsibilities and fertility preferences. And through these conversations, families may have couples may have recognized mismatched preferences, led to separation. They may have discovered aligned preferences, which made them more comfortable formalizing unions. So to conclude, we find that this shock to the expected cost of children is disrupting family plan. As potential parents sort of pause to evaluate the risk associated with Zika, women may form greater attachments to the labor market. Inter-household bargaining becomes more explicit, and couples may discover sort of previously unknown fertility preferences. So these interfamily adjustments have lasting demographic complications. Zika is unique in that it is a negative aggregate shock that has an immediate impact on motherhood. And when women as a whole are less likely to become mothers, employers may adjust their demand for female workers, and marriage markets may sort of adjust as inter-household bargaining evolves. So in the end, we find this one-time shock that leads to a lasting impact on fertility. With that, thank you. And
Okay. So still thank you for staying even longer. And this is joint work with Yamai Shannon. And in this paper, we ask whether active labor market programs can change the trajectory of low-income families and weaken the intergenerational transmission of disadvantage. And the question is what we know about that, and actually not much. From the literature of active labor market policies, usually they follow the individuals themselves over short periods. And there is not much information about what happens to their partners or to their kids. There is a large literature on how economic conditions of parents affect their families, but this comes mainly either from cash transfers or welfare reforms or tax reforms, or either from parental job loss. But we don't know much about how an intervention that brings parents into stable employment by building their skills can affect the outcomes of their partners or their children. So we try to answer this question by examining the long-term and intergenerational impacts of an active labor market program that focused on soft skill training. This was done through a large RCT implemented in Israel with nearly 18,000 individuals. And we are going to use comprehensive records from several administrative records and survey data, following these individuals and their family for 8 years. We look at the participants' unemployment, earnings, crime, marriage, fertility, and residential location. We look at their spouses' employment, earnings, and household income. And we follow their children, looking at their education, crime, and early labor market outcomes. I will not have time to show you everything today. So we just focus now on the results I can show you today. For the participants, we find effects on employment and earnings that still persist over 8 years. And we also find evidence for reduced criminal activity. For the spouses, we find that this intervention also have positive spillover effects on their spouses, increasing employment on the untreated husbands and wives, meaning that the household total increase in income will be larger than the income increase from the participant himself. And we also see that these effects, these benefits go through their children. We find a decline of 11% in high school dropout, and a large decline of 25% in juvenile crime, and an increase in the performance of the kids in matriculation exams and even in the likelihood of going to higher education. Across all these margins, we found that the benefits are concentrated mainly among those, the most disadvantaged families, mainly those who were Arab participants and the long-term unemployed. So the program was called Employment Cycles. The target population were unemployed income support claimants, those who were on welfare, age 20 to 50, and they have to report weekly to the local employment office. given that this is a very disadvantaged population, 43% were Arabs, 90% had 12 years of schooling or less, and 20% of single mothers. The objective of the program was to move participants into stable employment by building their soft skills. So it was soft skills training, such as motivation, self-efficacy, self-esteem, and building also very proactive work attitude. The format was based on group workshops and individual coaching, and it lasted between 2 to 7 months, depending on the specific needs of the participant and their baseline motivation. And participants had to come between 4 to 10 hours a week for this group and individuals meetings. This was done through a randomization. This was in the individual randomization within strata. So every month, a fraction of these long-term welfare recipients were randomly assigned in each office, and also by population type. We have 2 population types which will become important later on. We have what we call the stock population, which were the long-term unemployed, and the flow population, which were coming from an employment spell. As I said, the sample were 18,000 individuals. The control group continue reporting to the employment office as usual once a week. This RCT was every month, a portion of the individuals were randomly allocated. So the RCT lasted for about 2 years, between February 2014 until December 2015. So here is a part of our previous paper where we show the increase in soft skills for the treated group relative to the control. This was published already in last year. And we follow here individuals for around 18 months. Now I'm going to show you the long-term effects of the program. Here are the employment effects. On the left side, you see the treatment and control means, and on the right, the difference between the groups. The large drop you see here is COVID time. But you see that there are large gaps between the groups that, of course, during COVID time, both groups have a drop in employment, but still there is a persistent effect in employment after 10 months. There is a large heterogeneity in the groups, as I said before, and the main effects are among those who were long-term unemployed. Here we see for the long-term unemployed, we see an increase of 18% in the total number of months employed over the long term. And focusing only at the last point in year 8, it's still 8% increase in employment. For those who were new claimants, who were coming from an employment spell, we see that the effects more or less disappear after COVID. So both groups converge in COVID and the effects disappear. We also see large heterogeneity within the Jewish and the Arab population. For the Arab population, we see a very large increase in employment of 10% and 25% increase in overall employment. For the Jewish population, the effect dissipates after 2 years. As I said before, we see that the effects also are reflected into lower crime. We see overall 11% decline in overall crime during that period. And now we move on to see the effects on the household. We do see an effect on the untreated spouse. So there is an increase in the probability of working for the untreated spouse and the probability that both of them are working. And then we zoom in to look at the parents. Now I'm looking at the parents who have children age 11 to 18. The focus on these ages is because these are the ages that I can track the outcomes of the kids when they are in high school and post-secondary education. As time will pass on, I will be able to look at also the younger kids. But we see that consistent with what we see of the adults, we see that most of the effect come from the Arab families. These are the long-term unemployed. And we see a large increase in their earnings from work of 58% over the whole period. And we see again that the increase not only comes from the participant, the household, in the increase in household income is even larger, meaning that there is still a spillover effect on the untreated spouses. Consistent with the fact that we find all the effect on the Arab participants and not much going on the Jewish participants. At the end of the day, they converge. And in cumulative terms, there is not much of a difference. We do see when we look at the kids, and here kids age 11 to 18, we've tracked them all of them at the end of high school, we see a decline in dropout rates, an increase in matriculation eligibility, an increase in the number of matriculation units, and a decline in the probability of having a juvenile record. We also look at other stuff. We look at heterogeneity by age of partner assignment. We can split these groups into those who were age 11, 14, or those older children. And we see that most of the schooling gains comes from those who were younger when their parents were assigned to the program, but still for older children, we see a decline in juvenile crime. We don't see much of heterogeneity by child gender or by the gender of the participant who was assigned, whether it was the mother or the father. But remember that we do see spillover. So even if the mother was assigned to the program, we see also an increase in employment of the father. We do see some signs of we can follow these kids up to age 25, and we see signs of improvement benefits in the older ages. We see an increase in post-secondary education and a reduction in criminal activity. Again, all the effects are mainly driven from those who were long-term unemployed and their participants. So to conclude, we see that bringing parents into stable employment by building their soft skills can have broader benefits, reaching their spouses and their next generation.
Okay, thanks everybody for a great meeting, and hopefully see you all next spring.
Yeah.